Good morning, everyone. Welcome to this first event, Franco-German meetings for additive manufacturing. It is a pleasure to welcome you here today. We are going to have two very full days. Today is going to be dedicated to metal additive manufacturing, and tomorrow we will speak about polymers. I am Guillaume Moua. I am the director of A3DM, and I'll be the moderator of the 2 days. Now, I would like to thank the Franco-German Chamber of Commerce and Mr. Patrick Brandmeier here for his invitation to take part in such an event. I would also like to congratulate Monica Butterbrot, Sophie Cabot, Julie Courbon, and Martina Musso for their work and achievement in putting such an event together. AM is an ever-growing industry and family, and is constantly evolving and innovating. We'll have the chance to hear for the next 2 days speakers from both sides of the Rhine, sharing their knowledge, experiences, and know-how. This is an incredible opportunity to extend the Franco-German couple to additive manufacturing, a rather new but yet very promising industry. Now, with no delay, I'll give the stand to Patrick Brandmeier, CEO of the Franco-German Chamber of Commerce and Industry. Patrick, if you may.
Thanks, Guillaume, and good morning also from my side to everybody today. I'm really very happy to be able to accommodate all of you today. Obviously, would rather have like to hold this event in a, so to speak, analog way, but I think digital, the way we do it and have to do it due to the pandemic, I think it's a very accommodate for that type of event, also for the topic we're handling. As Guillaume mentioned, we have 2 full days. I think it's a very interesting and also very meaningful subject we will discuss in the next 2 days and hear all the expertise, all the competence we have on both sides of the Rhine, in both countries, in France and in Germany. And for that, I also have to thank the ministry in Germany, das Bundesministerium für Wirtschaft und Energie, who has been very supporting and has been also accommodating this event for us. I would also like to remind that this is the 7th event in a row which turns around the digitalization and the industry 4.0. And I mean, you all know how important that aspect is in current life. And I think we also see how the coronavirus and all the pandemic development has even now accelerated, I think, in many ways and areas, that industry and that technology. And interesting enough, it's, as we all know, not only affecting one industry. I mean, this is really a broad issue covering all industry, all branches. And we also see that is affecting a lot of companies, meaning it goes from startup companies having developed maybe a competence, a technology in one area, but also affecting large companies, as we will see during the next 2 days. Maybe to remind you just who we are here, the French-German Chamber of Commerce here in France. We are about 900 members on both sides of the Rhine. We are covering all industrial areas. Therefore, once again, I think this topic is very relevant because it speaks to a lot of our members, to a lot of our customers as well, who are really affected and dealing on a day-to-day basis with that technology. We have approximately 50 employees working in both countries and obviously also accommodating German companies willing to come and to do business in France, but also the other way around. And therefore, we also understand ourselves in a way as a facilitator between the 2 countries. And I think especially for that type of technology and that type of discussion, and also whether the technology currently is, I think at least we try to also play a major role in that regard. Then maybe please allow me to stop or to finalize here on a personal note. How have I been affected? I mean, personally, my personal life with additive manufacturing. I have to admit, I have been spent 25 years at Siemens, a major industrial group in Germany, working abroad. And obviously, I mean, already then, and this is 2 years back when I switched jobs, this was already a huge issue throughout the company. And I think we will also have and accommodate one person speaking. And I'm really happy to have also somebody from Siemens speaking today with that regard. I think Dr. Seibold will join us later. Then during the pandemic, two personal experiences. Number one, last year we saw on television when the pandemic started and we all needed those masks and all the protective gear. There was a young boy from a French school, 14 years old. He was able to use the additive manufacturing technology to produce a small plastic part, which was required to put into a mask, allowing then staff in a hospital to be able to treat people. And I think this boy alone was able within, I think, 2-3 days to set up his production at home and also then to print these pieces which were required in a large amount. And I think therefore was able to produce over the 2-3 weeks which followed 50 or 100 masks. And that was very impressive. And so this is really, I think, a good example of how this technology already affects today our day-to-day life. And also it shows how it is really present, not only in companies, but also in private lives and so on. A second example, I just read recently an article when we all heard about the Mars expedition, which was launched by the NASA and everybody, that they were planning when then sending maybe people one day to the Mars, that a lot of the equipment they will require there, I mean, for example, housing and everything, the idea and the intention and the strategy is really to produce all the pieces and all the equipment which they require to produce that on Mars with the use of additive manufacturing. And by that, I think everything is said, meaning it's a technology already working today and affecting our day-to-day life today. But I think, and that's maybe more important, it's also a technology which is about a lot about tomorrow. And I think therefore the next 2 days hopefully give then good examples, very good discussions, and obviously we also hope a very rich exchange between the German actors and the French actors in that field, hopefully then allowing both countries or all the companies to advance in their progress and in their works in that regard. With that, thanks a lot and good luck to us all, and I wish us some 2 fruitful days. I'm being reminded here, sorry, a final remark from my side, that there is a document in German, obviously then for those who read German, but which is then comprising all the aspects of the French industry, or it's the other way around, it's in French and it's, it's in French and it's summarizing all the information, relevant information about the actors, about the AM activities which are ongoing in France, giving by that a very good insight into the industry and into the activity which we currently have. With that, I hand back to our host, Guillaume. Thanks for that.
Thank you very much, Mr. Brandmeier, for this clear and full introduction. You're right, loads of inspiring stories about additive manufacturing. Now, just in order to explain a little how the event is going to be structured, so for the 2 mornings where I'll be moderating, it will be a mix of actual panels with several speakers actually sharing the knowledge, once again, as well as pitches from German startups or a bigger company explaining their innovation and processes. Now, we start today with the metal side of additive manufacturing, as said before, and we will switch tomorrow to polymers. Now, without further ado, let's start with the first panel, which will offer us actually an actual state and future of additive manufacturing across both sides of the Rhine. And for that, I'll actually welcome 2 participants. Actually, Jochen Lock from Fraunhofer IAPT in Germany, as well as Quentin Pétavy from the CETIM in France. So Jochen is actually head of academy at Fraunhofer IAPT, and Quentin is French additive factory hub coordinator, as well as a process engineer at CETIM. Now, hello, Jochen. I don't know if you can hear us properly and speak today.
Hello, good morning. Thank you.
Thank you for joining us. Hello, Quentin. Thanks as well.
Hello, good morning, everyone.
I hope you are both ready to actually share your experiences. I think we'll start with both of you presenting the German and French markets and the full landscape as well as your entities. So we'll start with Quentin. You can go. The floor is yours.
Okay, yeah. So thank you, everyone. It's a pleasure to speak about additive manufacturing today with you. So just maybe we can go to the next slide to introduce myself. Just about my background, I have a training. I have a master's degree in mechanical engineering at National Engineering School of Saint-Etienne, in which the last year was dedicated to additive manufacturing, in which I was redesigning ball bearing for automotive industry for additive manufacturing. I then joined CETIM as additive manufacturing engineer to work on metal binder jetting process. And I'm currently involved in Additive Factory Hub platform, as Guillaume told it, to work on laser powder bed fusion and more specifically on wire arc additive manufacturing process. So now I will present CETIM and CETIM activities. So we can go to the next one, please. So just a few words about CETIM. CETIM is a technical center for mechanical industry, which is situated in many parts of France in order to be the closest to the French industry. It was created in 1965 upon request from French mechanical industry in order to improve their competitiveness. It is a regional, national, and international player with more than 100 people, 1,000 people, sorry, working there with a turnover around 150 million, which is divided in two parts, which is a private research and development activity for company and collective research and development activity for all the French industry. We are organized in different business units which cover all the mechanical field, going from the study of metallic material to the fatigue, to test the power transmission, to simulation, to designing. And we have a special team which is dedicated to advanced additive manufacturing. So why do we have a team dedicated to advanced additive manufacturing? In fact, metal additive manufacturing is a process that is based on mechanical and material science research field, such as powder metallurgy, heat treatment, or welding, and that's why it's important for the CETIM to work on that topic, and it's as well a key technology for the industry of the future. So maybe I will say just a few words about advanced additive manufacturing at CETIM. So if you can just go to the next slide, please. Thank you. So it's a team. In that team, there is about 30 people working there with people that have more than 15 years of experience on those processes, especially on laser powder bed fusion, which is the more mature process. We can conduct activity from research with our research and development platform to material development to product development. So as you can see at the bottom, from the design, generative design, simulation and optimization, to manufacturing, proof of concept, and then selection and testing the best technology for your product. We can do training, which is customized program or on-site and e-learning as well. And we can do we can go on to industrialization and for qualification of the product to product validation. So I will give the speak to Jochen.
Thank you. So my name is Jochen Log. I'm working at the Fraunhofer IAPT. Since 4.5 years, I was responsible here for the academy, but now recently I changed my activities into business development and consultancy for automotive. And it's a pleasure for me to shortly introduce our institute and then discuss some trends here. So our institute, Fraunhofer, stands for Additive Production Technologies, Fraunhofer IAPT. It's located in Hamburg, and I think we are well known for our our pilot projects with industry and industrial partners that we have done in the past, also recently. yeah, our services conclude everything that is needed to implement additive manufacturing, starting with training and part screening services, going into engineering of parts, automation of post-processing, and quality assurance. So we are covering everything that is needed for industrialization of additive manufacturing.
So just a few words about general market landscape in France. The French ecosystem is composed of mechanician, it's composed of mechanician company, which gather machine manufacturer, service manufacturing, software supplier, research institute, and university. It's kind of the same ecosystem as in Germany. Jushan will explain it later. But for some process, maybe it's less mature, such as laser powder bed fusion. A fact in France is that democratization and appropriation of additive manufacturing in industry requires large and multidisciplinary research and development skills. And there is no private company or few private companies that can develop by themselves research and development program. With COVID crisis and with liquidity problem, it's necessary to coordinate and mutualize and share resource and problematic on additive manufacturing, research and development topic in order to ensure the development of the sector. And that's why CETIM is a key partner of this ecosystem, has regionally and nationally, in order to ensure the development of the sector. And we are coordinating a different activity in which we are mutualizing research and development activity.
So now some German perspective on the German additive manufacturing ecosystem. I think we have maybe one of the leading ecosystems in the world in additive manufacturing. This is due to we have a strong, on the one hand, OEM base, for example, in automotive, aerospace, but also, for example, in train companies who are pushing this topic and having the budget to invest into these innovations and are driving with their applications in industry. And they're well networked with other players, like, for example, the manufacturing service suppliers for additive manufacturing, which appeared over the last years, who are often small to medium-sized companies who are specialized into production of additive manufacturing components. But also in the manufacturing supplier base, I see some changes. I think that now the tier one supplier that are already tier one supplier for other production technologies are very mature as well. So we have a strong competition from them to the previous supplier base. And I think a lot of the business that is now going into serial production will be produced at tier one suppliers. Then we have the machine market and also some software ecosystem in Germany. But I think the most obvious one is the machine market, where we have quite diverse machine manufacturers in different fields. But I think, of course, the focus and concentration is on the laser powder bed fusion, where we have most of the major players worldwide in Germany located, and where we have a really good market position here. But I also want to say that the upcoming technology, for example, of binder jetting, we don't have this major player in Germany yet. So we are also having some holes here in the machine supplier market. Last but not least, for the diffusion, but also for the innovation, and it's important to include universities and institutes like ours. And we have a lot of R&D infrastructure in Germany that is very closely connected to the industry and is working very closely to fill the gaps that are open here. And I think our institute is at the forefront of this development and R&D services.
So now,
Thank you both for those inputs. I think everybody understood better the difference in between the two markets, even though it stays quite close. Now in the structure, I think we've afterwards decided to speak about your inputs about technological trends. Jochen, we are listening to you in that sense. Can you give us your thoughts and inputs about actual technological trends in additive manufacturing? Jochen, we have your microphone is actually off.
Yes, thank you. I think there's actually also a slide or two slides dedicated to this topic. Anyway, I can start discuss this. So what I see in terms of technology is that the laser powder bed fusion over the last course of years matured a lot, and it's still not where conventional manufacturing technologies are, but I think we have a baseline maturity that is sufficient for small serial production, for example, in aerospace and automotive, or at least very close to it. So some players are a little bit in front, some a little bit behind. And I think there are also new technologies and metals that are getting maybe in future or maybe even now some breakthrough. So I see, for example, the DD process here that is, in my feeling, getting its breakthrough at the moment or very soon. We're seeing more and more applications here, and it's going out of the niche application of coating, for example. In terms of binder jetting, I see some it's, I would say, the hottest topic maybe at the moment. It's highly investigated in automotive because it's scalable, and maybe the process of additive manufacturing that most likely go into full-scale serial production and has a better cost advantage than the laser powder bed fusion. I say maybe because I think there's a question mark behind this still, because binder jetting is not that mature yet as laser powder bed fusion and has to overcome some hurdles. Also, I want to not forget polymers, which sometimes is a little bit overseen. I think that most of the money that is earned today actually is earned in polymers. For polymers, it's really an established alternative, cost-efficient alternative for small lot sizes to the injection molding. So the projects that I saw was IC, where a lot of money is saved, are often also polymer projects. So these are some general technology trends, but I want to say also specifically something to the metal technologies and laser powder bed fusion. I think there are four main challenges discussed over the last 4 years. One is quality assurance, another is cost reduction, post-processing, and education. I think in all of these fields we see progress. So for quality assurance, we see slow progress, but we see some progress here, process in terms of understanding how to assure the quality of the parts. There are first standards available now, but of course still there's room for improvement. Another field that was always critical or is always critical is that we need to reduce cost in additive manufacturing to be competitive. And I see some progress visible coming from two sides. One side is that we see progress in terms of that the machine prices are dropping, and there are low-end manufacturer with prices that are way lower than the actual machines. So this is one direction, and the other direction is that we see high-end machines with high productivity. For example, the 10 laser machine that was just released. Also, I see still in the process and in the process parameters a lot of space for improvement. So I can see some relevant cost reduction for the close future here as well. Another field, sorry, can you go back? Okay, another field where we progressed a lot is in terms of post-processing. We had a huge gap here in the past. I think now we are starting to understand better how to post-process the parts for additive manufacturing. Still, I think this is still a big cost reduction issue, and at our institute, we now want to decrease post-processing cost by, for example, applying automation. Last but not least, we want to highlight also the educational part. I think that now there's a broad offer of knowledge available, at least B2B and B2C, and yeah, a few certification courses are coming through. And also what I would say is where we still have a lack, at least in Germany, is curriculums in universities that are structured and yeah, having a strong focus on additive manufacturing specialist. Okay.
Yeah,
I think this is not 100% technology trend, so maybe it's good time for Kenton to continue.
Yeah.
Yes, thank you very much, Jochen. I think yes, it was your turn, Quentin, now to actually share your thought on technological trends.
Yeah. Could we just go to the slide? Yeah. So as Jochen said, the cost reduction is really important in order to industrialize additive manufacturing. That's why indirect heat input process are emerging, like metal binder jetting, which is scalable and could be a good process for mass production. It could be used for automotive, but the situation for the moment is that it's a process that it's not mature enough compared to laser powder bed fusion, and laser powder bed fusion is highly efficient for performance when you're looking for performance. And there is other process such as DED, which are really interesting for aerospace and energy sectors. In order to produce maintenance components or near-net shape components. And there is also other emerging additive manufacturing process that are emerging and that needs to be investigated. So you have to keep in mind that before going to additive manufacturing, you have to select the right process depending on your product. So if you're willing to do a small parts, maybe binder jetting, maybe laser powder bed fusion could be the right process. If you want to do a large parts with several cubic meter, DD process will be efficient for your application. Then the surface roughness is better for indirect process, but it's a compromise with part performance. And then you have to look at the productivity. So the binder jetting, you can see that the productivity is around 100 cubic centimeter per hour, and the machine manufacturer say that it could go to 12,000, which is just an announce for the moment, but it's really scalable. And then you have to choose between the cost of this technology.
Thank you very much, Quentin and Jochen, for this input. So you've already started answering a few points of actually the next question, which was perspectives and current limits of additive manufacturing. Is there any things you would like to add to what has been said, or would you like us to move to the success stories you wanted to present?
I have a question to Kenton actually, because I see, speaking to French customers, that DD has a lot of attention in France compared to Germany. In Germany, of course, there's also from certain industry attention into this, but my impression is that there's a big interest into DD in France. Why is it so?
Yeah. I think DED is highly efficient for large part in small quantity for maintenance component, for example, because it won't request tooling components, and even the lead time will be better if you produce the part with additive manufacturing. If you look at casting component, you can have casting or forging component. You can have a component after several months. For maybe 1 year, depending on the components. And with additive manufacturing, you can see that you can produce the part in just a few months. So even if the parts, just the production part is still more expensive than casting, the lead time is where the company are see the interest of additive manufacturing. And that's why energy and oil and gas, hydraulic, and maybe in the second time, nuclear company will be interested in GED.
Okay, that's interesting. Thank you.
Thank you for those questions. So we have a timing to actually follow. It's already 9:30, and we have until 40. I just remind to the participants that if you like to ask questions, please don't hesitate to do so in the chat. We already have a few ones for Jochen and Quentin. So we'll move to the success stories, gentlemen, if you wish. That way we can keep on going forward with your presentations. So Jochen, could you tell us and show us a few success stories?
Yes.
To share?
So I want to speak about one success story of last year in our institute, as with many others. Maybe next slide. And I think that many experienced this, and it was getting a lot of media attention, that fighting COVID crisis using additive manufacturing was very interesting and a bit stressful time, but we had a lot of activities here in the institute. As many others, we've been also active in the face shield production, and we worked with Decathlon together on dual adapter for the Easy Breath of this kind of masks that were this diving mask that were re-engineered for respirators, and also we had some respirator systems designed very short time to market, and with using also additive manufacturing. And what I want to highlight here is that the current crisis, of course, putting a lot of pressure on the market. So I think that the business will go down. There will be consolidations in the market. Maybe market variety will shrink with additive manufacturing in the next years, with all the frozen budgets at the OEMs. But on the other hand, there are also maybe new markets appearing. I think that the whole COVID situation was showing very well the abilities of additive manufacturing, and might give us some push for the medical field and hospitals, so we can diffuse better in this new market. So this could be really a chance for additive manufacturing, as well as I think additive manufacturing is low volume production technology with a high flexibility. And I think this will get more important over the next years. So to reduce tooling costs, to reduce fixed costs will be a hot topic. And I think additive manufacturing can do a contribution here.
Thank you very much, Jochen. You're right that we see a lot of new projects going on in medical since the crisis for additive manufacturing. Now, I think, Quentin, you also wanted to share more industrial, very industrial, marine, naval success stories.
Maybe. So it's just to say that despite the COVID crisis, the company that were involved in additive manufacturing keep working on it, and we have few success stories in France about it. So it's the case with Naval Group, which is a French company who have integrated their first additive manufacturing propeller made by WAM on a French Navy boat, which is a really good thing. And then Safran for aerospace have a plan to open their additive manufacturing plants in 2021 in France, next to Bordeaux. And even smaller companies are keeping working on it, and it's the case with EAC, which is a luxury manufacturer components, who have integrated their first metal binder jetting to produce parts for industry. So the innovation has been slowed down due to health and COVID crisis, and that's why also it's important to mutualize resources and to share problematic in order to ensure the development of additive manufacturing.
Thank you very much, Quentin. It is true that, as you said, it goes through all sectors, and we do hope that it keeps on going like this. And as you said, it would be good that people share their experience and knowledge in order to have the industry move forward. Now we'll jump to the last question, and before having you answering the question of the participants, now we wanted to talk about education. and see what is the role of education in additive manufacturing and how is it structured on both sides of the Rhine. I think we wanted to give the floor first to Quentin, and we will jump afterwards to Jochen. Quentin, it's yours.
Yeah. I think the situation and the democratization is better than 5 years ago, which additive manufacturing was more onto aerospace and medical activity. Now we see that the French University for Mechanical Engineering, Material Engineering are giving the last year a specialization in additive manufacturing, and we see more and more students going on the market which are specialized in additive manufacturing. I don't know in Germany what's the situation, Jochen?
So what I see in Germany is that that we have a lot of offers that are focusing B2B business. So in the past there was a lack of this knowledge, but I think now that the knowledge is more and more, as you said, democratized. So I think that the knowledge is more widespread, and there is a general knowledge of additive manufacturing in the market. And what I think is important for the future is that we have specialized people coming from universities, and at the moment I feel that in Germany we are lacking a bit behind in this development. So in the universities we don't have too many curriculums in this field, and I think we need to improve here. Even though we have a good B2B base, maybe we need more specialists for the future. Also, what I want to highlight is that we have still a lack of, or just a few certification courses. I think it's also about the uncertainties, because we don't have really this additive manufacturing operator as a standard, I would say, work, and in German we call it Berufsbild, and this we need to still develop our professional base for specialists in Germany, at least from my perspective.
Thank you very much to both. We still had many questions, but unfortunately we're running out of time. So Julie, I think we had questions from the participants. Could you enlighten our speakers about it? Julie, I think your microphone is off.
Yes. Good morning, everyone. I'm Julie, live from Berlin. I'm happy to relay the questions of our public. So I remind you of this option in the chat. So maybe shortly for you, Jochen, in a few words, because we're running out of time. Is there any national policy about the development of AM in Germany? You just talk about education. How is the collaboration between SMEs and the Fraunhofer, for example, regarding that? And maybe a second question to both of you. Relating to the number of metal technologies currently available, do you foresee any current technologies overtaking the other and becoming maybe redundant? It was a question also regarding FFF technologies.
Okay, thank you. Yeah, of course, there are several, if I understand the questions right, several activities to connect institutes like ours together with SMEs. Some of them are more focused on funding opportunities that we have and that we can apply together for. So there are special fundings where we cooperate very closely with the SME industry, but also there are, I would say, unstructured activities like, for example, direct B2B business that are dependent on some application. And also, of course, there are structures and networks with the SMEs. My feeling is that this could be enforced more, at least for our institute and our region. But I think there are different approaches going into this direction, different activities to connect and share the knowledge. To the second question that was, I think, dedicated to both of us. I think that it will be a very interesting development between binder jetting and laser powder bed fusion. Some say that they are complementary, but I think especially for automotive, there could be some competition in the future. I see that the laser powder bed fusion might decrease in quality, maybe gets to the standards of the binder jetting in terms of porosity and so on, and therefore does some cost increase, some very significant cost increase, which could make it competitive for serial production. On the other hand, we have with the binder jetting the main backdraw that we don't have aluminum for automotive, and at least there are claims that in future you can print or not only print but also sinter aluminum, and this would then be a direct fight between laser powder bed fusion and binder jetting, and we will see how it turns out. I like competition, so we will see. I think both have to stretch in order to get ahead, but for me it's not clear who will do the main business in future, but we will see how it turns out.
Thank you, Jochen. Quentin, do you have as well your opinion on that?
Yeah. I think for my metal binder jetting, it will be more competitive regarding casting and conventional parts, and it will be more complementarity with laser powder bed fusion, and that's why I don't see metal binder jetting taking all the market and laser powder bed fusion taking out of the market. I see both of them in a high level. I can't say which level, but I see both of those processes emerging in the future.
Thank you very much to both of you. We are nearly on time, 1 minute near. So German organization, perfect. Thank you again to both of you for the input. I do believe we all have a much clearer idea now of what's happening on both sides of the Rhine. I'll let you go to your occupation, and on our side, we'll jump to the next session. So thanks again, guys, and then you have a very good day, and hopefully we'll be able to meet again in the near future, but physically.
Thank you.
Thank you very much.
Thank you to both. So now let's jump to the second part of the day. As said earlier, we are going to have now some pitches from German companies, 5 minutes each, in order to present their companies and innovations. So we're going to start right now with Mrs. Audrey Haberer from APWORKS, who is going to present her company and her innovation. Audrey, it's your turn. You have 5 minutes.
Yes, thank you. And hello, everybody from my side. Can you see? Yes. So, hello, everybody from my side. So this is a pitch of German companies, and for APWORKS is done by a French girl. So I'm Audrey Haberer, technical consultant at APWORKS. APWORKS is a 100% subsidiary of Airbus. We, with Premium Aerotech, 75 employees working on AM topics. At APWORKS, we are more focusing on SLM solutions, and on Premium Aerotech side, we're also dealing with SLM solutions for titanium parts, but also with the DED process. So we have one of the biggest machine park globally. Here you can see the 9 machines we are working with. We are dedicated to aluminum parts, scam alloy parts, and ALSE10 with quite a big chamber volume, like 400 times 400 times 400. We can support you from the beginning to the end, so from the design of your part to improve the performance of your part. We have a dedicated engineer team for that, to the machining process. And every step of the production or of the development is done at one place. So this allows us to have the very short lead time for our customers. To produce in a good quality is, of course, a good start, but we want it to be innovative. So these are typically the three directions we develop. Why can't you see my screen again? What happened? So as I told you, we are the three USP. The first one is the scamalloy one, which is the strongest aluminum alloy developed specially from Airbus to 3D printing application. You will notice the specific strength, which is quite high for an aluminum, but you benefit also a good ductabilities similar to titanium. The next one is the 3D surfing process, which improving the surface quality, because you know AM parts are a rough surface. So this is a polishing process made with chemicals. And the last one is a system to join metal parts to composites. So we basically added some pins on the metal parts to make the junction. And of course, at Airbus, we did a lot of tests for this, and the tests show that the result is quite very good compared to the traditional way of bonding. If you're familiar with trade show in the past, you may have seen this show parts, which is called the Light Rider, the first 3D printed motorcycle. The frame is only 7 kilograms, and the bike itself is like 35 kilograms. The frame is made of scamalloy. It's quite a big part, and you can see there's some junction here, which are welding elements. So the goals were to show to the public that it is possible to print big parts made with AM. And this is basically the process we are going through to find the final geometry. Of course, expertise is needed from picture 3 to picture 4. This is where the magic happens. And this is where we have invested a lot of work from the engineering team. So because of origin, we focus first on aerospace application from military airplanes, but also for civil airplanes like A350. A trend is, of course, this flying taxi. We equip the Airbus taxi, city taxi with this code plate, and also some application for satellites. A process for titanium parts, as I said at the beginning, is fully qualified from the product to the NDT, according also to Airbus and EASA standards. The next field, which is also a big one, is the motorsport, especially when it comes to shorter lead time. And scamalloy especially makes sense for safety critical parts like roll-up structure. And you may also have noticed effort on Bugatti exhaust finisher. Also some thermal application with a lot of development work, and also for electronics components. And the next one and last one is about general industry. We are looking also for other fields like oil and gas or sailing racing boats, robotics parts as well. And we developed also last year this genome toolset in order to produce customized product. And we have, of course, many more customers. If you have some question, I can hear your question.
Thank you very much, Audrey. Actually, for the questions, they will be asked at the end of the session. Okay. So to all participants, if you have any, please once again write them in the chat, and we'll go back to them in a few minutes time once we've done the 4 pitches. So thanks again, Audrey, and we'll speak again during the question time. We go now to the second pitch presentation. We'll welcome on the stage Daniel Beck from Bionic. Daniel, it's your turn. You have 5 minutes as well.
Good morning. Thank you that I can join that conference. It's very impressive to see all this information. It's great to have also the chance to share the content, what we do with Bionic Production as company to France. So we are quite happy to participate. So let's start. I hope you can see that slide. We belong to the Port of Hamburg. Since 2019, our company is originally a spin-off since 2015 from the Laserzentrum North, or today Fraunhofer Institute. And we are located in North Germany, close to Hamburg, and we understand ourselves as a specialist for bionic AM designs and mobile printing. So we do have 2 different kind of businesses that we support right now. If you look to our product portfolio, we have two big main focuses. So the first one you see on the left side, these are the technical services. And these technical services consist of the introduction of 3D printing in general to our customers. That means we do part screening projects. That means a customer come to us and give us a boom list and say, hey, where is the 3D printing potential? And we do a professional part screening with a special software to identify these potentials. And as soon as this is done and the components are identified, we go into the second step and we make a redesign in a lot of cases with the bionization. Yeah? Bionization means we copy a concept from the nature and transfer that into technology. Yeah? And this bionization process is quite useful because sometimes there are much better results than completely computer-generated simulation results. And then, of course, we do the classical AM engineering. When the first step is done, we have the components and they are redesigned. We go into the second step and produce these components in the classical way from a prototype to serial manufacturing. So we do this by ourselves with our own machines, but of course also with our partners in Europe. And the third step, that is the mobile printing. That's a completely new business that we established since roughly 1.5 years. This is in very easy word, a 3D printer in a container. And this 3D printer is a mobile system that is using WAM as technology, wire arc manufacturing, where we can produce these bigger components as you see here in the middle from the dimension 700 to 450 millimeters. And these components are very useful in the oil and gas industry, in the mining industry, in the rail industry. And the system at all is very useful to make hybrid repair jobs. So it's quite a good system for that. And this system is also part of our business. But coming back to the original generic business that we do, it's the bionization. And here you see a little example that's quite funny. That's a hedgehog. And everybody know a hedgehog, and these hedgehogs are falling very often down from a tree from heights like 8 meters, 9 meters, and they never damage themselves. Why they never damage themselves? Because their squills, as you see here, they have a special shock absorption structure inside, and this shock absorption works like a domino effect. And we have, for example, right now a project running with a huge bus and truck company who is copying this concept into their bumper, into their front bumpers of their buses to avoid or to have better results during the crash test. Yeah, and this is, let me say, an idea, a pattern from the nature that we copy into technology. Another nice idea is that you see here from the banana leaf. The customer comes from us, from the aviation industry, with this titanium mask and say, hey, I have a problem in this frame with the stiffness here. Because of the pilot's nose, there is a little angle inside. And of course, the stiffness have an issue if there is an angle. And we say, where is the similar concept in the nature? And we found the similar concept in the banana leaf. The banana leaf, as you see here, is very thin at this area, but it has to cover a very huge weight. And there is a little angle here. And we looked into the banana leaf and found this special oval formed empty chambers, and we copy these special form into that frame, and the result was that we solved the stiffness problem for this mask. And of course, we generate a lightweight design on top. So that was a very nice example also from the nature that we transferred into a technical solution. Another very famous example that you may already know is from Bugatti, where we designed together with Bugatti a brake caliper. It's the biggest titanium component in the world. That's a functional part where we mix two disciplines. One is the topology optimization, computer-based plus bionic design ideas from the bird bone structure, where we generated in cooperation with other partners 41% less weight, and generated also in this very tough environment, as you see here on the testing, with high temperature, a high stiffness of the component itself. Yeah. So this is also a very nice example what is possible to copy bionic design into the real world. Another example is, for example, for the fluid and flow optimization. That's a nice example where we combine also several components to one and have a better design of a cooling lubricant that can be transferred to the right point of use and make also functional integration. That's classical AM design, also combined with flow optimization from the bionic side. So that's all from my side. Merci, in the round.
Thank you very much, Mr. Beck. You were just on time, so thank you. Once again, if any participants have questions, you can add them in the chat, or if you've actually registered to the B2B meeting for this afternoon and have maybe more confidential questions, of course, you may ask them later on. So thank you again, Mr. Beck. Very good day to you. And we are going to go now with Davide Iacovelli from AOS. So Davide, it is your turn, and you also have 5 minutes. Hello, Davide. We don't have you with us. We cannot hear you, unfortunately. Can you check your microphone and camera?
Yes, now it should work.
It is working. Please go ahead.
Yeah, perfect. Thank you very much. Good morning to everybody. My name is Davide Iacovelli. I'm regional director at EOS, responsible for the business in Europe, Middle East, Africa. So first of all, I would like to introduce you who is EOS. EOS is a family. Now it's working. So EOS is a family-owned company located in the near of Munich. Is a technology market leader in industrial 3D printing solution. We have 30 years of experience in additive manufacturing. As you can see here, we have a global footprint. Our portfolio consists in AM systems, materials, both plastics and metals, software, services, and consulting. We have the biggest installed base worldwide with 3,750 systems, pretty balanced, so 54% metal system and 46% polymer systems. What is our vision? Our vision is that additive manufacturing is the key technology for advanced industrial production and the key technology for digital factories of the future. As you can see, several customers have already ramped up this technology in their production along different industrial verticals, so aerospace, humanitarian, mobility, and energy. And what have these industrial companies in common? So they are facing similar challenges as a faster time to market, productivity increase, need for cost reduction, flexible production, innovation, customization, and sustainability. And additive manufacturing is exactly providing unique advantages to those challenges. As you can see here, 3 main and 3 key advantages: freedom of design, so lightweight, bionic structures, as also has been explained before, functional integration, load phase 1, and customization. We have the freedom of materials, both, as I said, metal and polymers, and we have the freedom of manufacturing, digital manufacturing, but also, especially in the frame of COVID, becoming more important, distributed manufacturing. This means decentralized production.
Mr. Iacovelli, I need to interrupt you. I'm so sorry. Some of the participants are communicating that they cannot see your slides, so maybe it's connected to you. Can someone of our team in Paris share the presentation of EOS? We will just make a little switch.
So at least in my screen it is written that I'm currently connected and sharing.
I can also see the screen.
Yeah, it seemed that everything is working as well on our side. So I don't know, maybe a connection problem from the participants. But
yeah, the participants are reacting. Some of them say it's okay now.
All right, maybe just a lag problem.
Yeah.
So sorry,
Great.
David, you may continue. Sorry for that.
No, thank you very much. Thanks. Yeah, as I said, last point was, let's say, also, which is very, very important in the frame of COVID, so resilience, global supply chain, and that's also key advantage of the technology. So just to share an example, a current example, to show what are the benefits and what did we achieve. This is one part of a A350. It's a safety class 2 component, so very high requirements in terms of quality. It's a door lead shaft, and on the left-hand side you can see what has been achieved. So a 45% weight reduction, 25% of cost reduction, and we could transform 10 parts conventionally produced into one 3D printed part. And this leads on the right-hand side to further benefits. So if we look into a complete business case, this is leveraging a benefit of roughly 90 million euro, fuel cost reduction of $20,000 per plane, and also CO2 reduction of 7,000 pounds. So also in terms of sustainability, it's becoming more and more important. So higher value at lower cost would be, let's say, the overall message here. We have several other examples, also in the humanitarian, medical, and the energy, as well also in the polymer industries. Also the well-known mascara brush, where we were able to produce actually 80 million of parts. So as you can see, the technology is a very democratic technology. Let's say it's crucial for small companies, for bigger companies, for small production, but also for bigger production lot sizes. What's next is something that's, let's say, a peek into the lab, which I would like to share with you. So we are not talking anymore about 1, 2, 4, 12 lasers, but about 1 million laser diodes. That's our new technology, which will, let's say, where we will be as productive as injection molding. So we can increase the production speed by factor 10. We have lowest cost per part. And that's actually a good example also how we can realize, let's say, customization of mass produce parts utilizing the benefits of 3D printing. And just to give you an indication, so if you have a part which has the size of your fist, we will be able to print it in 9 seconds. And there you can derive that it's no difference if you print one part, 10, 100, whatsoever. And last but not least, to share in the last slide, so of course, EOS can also support you in ramping up in order to be faster and to achieve better results. This is a short overview about or a short extract of our customers and service providers we are working with. Yeah, if you have any question, appreciate and looking forward to answer them. Thank you very much.
Thank you very much, Davide, for this clear presentation. So as you said, people with any question can actually once again ask them in the chat. We'll jump now to the last person for this first pitch session. So we'll move now to Steven Ergen from KOLIBRI. So you also have 5 minutes to tell us more about your company.
Thank you very much. Do you hear me very well?
We do indeed, yes.
Great. I will try to hurry up since we are to get back in time, and yeah, since we do that every time for our customers, it shouldn't be a big problem for me. So my name is Shivan Ergen. I'm the Chief Operations Officer of KOLIBRI Metals. Hello, ladies and gentlemen. Just to tell you a little bit about our background, KOLIBRI Metals was founded in 2016 as part of our sister WIBO. WIBO is a tool and die maker for the transmission industry. And we are a small startup with about 6 employees, which focus on doing AM services for our customers and for our own needs. So what we are good in is to print HSS steel with a high carbon content. And we do have all these resources our sister company has, means we can grind, we can turn, we can do the EDM. So we have a lot of opportunities to work on our parts we produce for the customers. The company, like I said, was founded in 2016, and our core business is to mix own materials, our MMCs. And we are one of the first companies who are able to do that. Just to give you a quick overview of our materials we use, by the way, these names are volcanoes, where in South America, yeah, where the KOLIBRI lives. So what we do is, like I said, to use, sorry, I need to go back. Use high carbon content materials. To give you an idea of our material metrics, you will see the difference. The conventional produced steel, rolled steel, cold steel, has a structure as you can see on the left side. Our additive KOLIBRI material steel has a structure like seen on the right, which provides you a lot of benefits against rear resistance, against abrasion, and we customized our machines to be able to produce parts with a homogeneous structure, as you can see on slide. And what we also do is we put into our material carbide or diamond powder to have a much better hardness and a higher hardness, which allows us to have much longer lead times for our materials and for our parts we produce. And we also to show you classification of our material to get an idea. You can see on the following slide that we have the same toughness and feed speed as coated HSS, for example 1.3343. Sorry. And we have the same hardness as hard material, and that makes our material pretty unique when it comes to rear resistance and hardness, of course. It was really difficult to show you one example, but we decided to show you our roll jaws. Roll jaws are used for the screw production, and we work with all the big manufacturers for the screw production. And do you still see my slide? Okay.
Yes, we can. And, please go ahead.
Yeah. Sorry. And yeah, like I said, it was really difficult to decide which showcase we would show you. But we do cooperate with all big manufacturers for screws. And what you can see on this slide is that we usually build these, as an example, hybrid, means we do add our high value material on a grinded surface of a less valued material, which allows us huge lead times. For example, a roll jaw needs up to 8 or 12 weeks in development processes. What we did, we reduced that to 1 week, including heat treatment. And we also noticed, since we worked with a lot of customers, that our material we do mix, including carbides, is much more resistant against abrasion. So we increased a time of use of about 50% for some cases. So it depends, of course, on what kind of screws they are producing with these jaws. So it isn't difficult for us to double the lifetime. We also before we start to produce with our material these jaws, we dry our material, our powder, sorry. We dry it because that's another business we are working on. We dry our powder to have less cracks in our parts. And as you can see, the surface of the roll jaw is unique, and you do not have to rework it. So you can take the roll jaw right after the production out of the machine and send it to heat shrink and send it to your customer. And again, it's a perfect picture how you can imagine how it works. So you have on the bottom the grinded low valued material, on the top our added KOLIBRI material. And yeah, that's all. If you are interested in anything or having questions, just let me know. Thank you.
Thank you very much, Shivan. It was a very interesting presentation. Now we all go to Q&As. I think, Julie, we have a few questions for our pitchers. So I'll let you ask them directly to our guests.
Thanks, Guillaume. Yes, we have so far 2 questions. The first one will be for APWORKS. Comes from Pierre Michaud. Is skull mallow available in wire feedstock, or do you sell the powder exclusively?
So both. As we sell the powder and we also print parts, but I have to say mostly we print the parts. For the powder, especially if it's in big quantity, we will refer to partners. And for printing the parts, recommend to directly deal with us because you can benefit 10 years experience with printing with this alloy.
All right, thank you. And for EOS, maybe could you give us an idea of the production speed of the machines per hour at EOS? Where does EOS stand in that matter? It's an important technological frontier for additive manufacturing.
Hello, is it related to any technology? I mean, if we are looking into laser perfusion technology, the last slide that I show, so here we are, let's say in terms of production speed, as I said, a rough indication would be a part with the size of your fist would be able to be printed in 9 seconds. If we are looking onto the current system that we have at the moment, this really depends a lot on the part size. We have very, let's say, small print shops and very large print shops. So yeah.
Thank you. I think it will be all from my side. I give the floor to you back, Guillaume.
All right, thank you very much, Julie. I mean, we are perfect on the timing this morning. Quite amazing. It's always very hard to keep a good timing on events, but I mean, everybody's been actually playing the game, if I may put it that way, this morning. So that's all for the first pitch session. For those who once again have the B2B meeting this afternoon, I'm sure you'll be able to exchange with those companies. And for us, it is time to jump to the second panel of the morning, on which we'll actually ask the question whether AM will be an essential component of tomorrow's energy. So now, in order to discuss that matter, we'll have 3 very high-level individuals with us. So we welcome today Mr. Markus Seibold. Markus is actually Vice President of Additive Manufacturing at Siemens Energy, as well as Material Solutions. Hello, Marcus. Thank you for joining us.
Hello.
We'll have with you Jonathan Moulin. Jonathan is actually the wire arc additive manufacturing product developer at Vallourec. Good morning, Jonathan. And last but not least, we'll have Mr. Yang Shen with us, who is a project officer for additive manufacturing at EDF. Hello, Jan, and thank you for joining us as well. So before going into the questions, we'll do as the previous presentation, meaning that I'll ask you actually to present briefly your company and mostly what is your actual state in additive manufacturing, your application, best practices, and we'll afterwards move forward within the questions. So we'll start with you, Yang. Can you please start with a brief presentation of EDF and your applications in additive manufacturing?
Okay, can you hear me?
We can hear you clearly, yes.
Great, thank you very much. So my name is Yang Shen. So I, as you said, I am a project manager in EDF Research and Development, in charge of advanced manufacturing project. So just some words about EDF. So EDF is an electric utility company. We are first electricity producer and distributor in Europe, the second in the world, and in terms of installed capacity, and the first nuclear operator in the world. So we are operating nuclear, hydraulic, thermal, and also renewable power stations all over the world. So EDF is not a manufacturer of parts, of components, but just end users. So why are we interested in additive manufacturing? So I will go to next slide. Yeah, okay, thank you very much. So one of EDF's main mission is to ensure the proper functions of its power stations all over the long term. So this involves regular maintenance and consequently the repair and manufacturing of components for its electricity power stations. So additive manufacturing makes it possible to optimize maintenance by more repair cases and also by manufacturing of spare parts at short lead time, so solving some obsolescence problems. So for new build, we would like to fabricate heavy component by additive manufacturing in order to reduce manufacturing lead time and improve component quality in terms of homogeneity, in terms of properties, and also aging behaviors. So in the near future, additive manufacturing may help us to increase performances by design optimization, by structure lightening, and also by using of gradient materials. So just some examples of specific needs for nuclear applications. So we need some appropriate specifications in compliance with safety rules. We need codification regulatory requirements, so based on development for conventional industry. And also some specific needs about the long-term operating aging behavior, both for components and for systems based on plant lifetime management requirements. And last but not least, the monitoring, control, surveillance, and mitigation process are also some needs for EDF to develop additive manufacturing. Can you go to next slide? Thank you. Just some examples. The first example here, it's a shutter valve, which is broken during the operation. So this is the obsolete part because we don't have the historical manufacturer of the part. So what can we do? We did redesign of the parts by 3D model in terms of geometry and also selection of materials. And then the manufacturing of the part by SLM process, selective laser melting. And then in a machine for 2 days of a part printing and also post-process surface treatment. And then we get the parts, several parts for just 2 days. And then we did the test in pressure test, 6 bars pressure test. And then we installed this part in our nuclear station. This is for the Belleville nuclear power stations. This part is under operating in our nuclear parts. And then with Additive Factory Hub, we are also working on some other parts. For example, here, some fuel control parts on steel, stainless steel. So what are the benefits? We used additive manufacturing here, the SLM process, to reduce manufacturing lead time. So we can treat obsolescence problem by reverse engineering and rapid manufacturing process. And then by this, we can reduce stock. But still, we need to demonstrate some other technical issues, for example, technical feasibility of the manufacturing, the in-service behavior, for example, fatigue, corrosion, irradiation, nuclear applications, the qualification of these parts, and then optimization of design. Okay, can you go to next slide? So we are also working on other processes. For example, the hot isostatic pressing process for the replacement of cast component, big cast component from metallurgy of powders. And then the WAM process, wire additive manufacturing, for manufacturing of heavy component. For example, some vessels, turbine, blade for our hydraulic stations, power stations. And then the cold spray process and the LMD process for the repair of parts. For example, here a spear of the hydraulic power station and a valve cover for our nuclear power station. And lastly, the power SLM process for the manufacturing of spare parts. For example, here some the anti-debris filter for irradiation internal of RPV, and then the valve body for some ESPN, some pressure component. Next slide, please. Okay, so EDF, we are supported by the industrial and academic partners to use our skills in metallurgy, mechanic, simulation, and also other skills to understand the performance and limit of processes for the additive manufacturing. So we are trying to use all this additive manufacturing in our nuclear and hydraulic and power stations. And also we need the industrial sector towards the standardization and the codification of additive manufacturing process. This is very important. Thank you very much.
Thank you very much, Yang, for this clear presentation. So now to keep on going on those presentation, I'll ask Marcus to actually explain us where you stand at Siemens Energy and Material Solutions. It is your turn, Marcus, to tell us a bit more.
Thank you.
Yep.
Will someone bring up the slides?
Yep.
All right, fantastic. So thank you also for the opportunity of being part of this this conference. And I'd like to quickly, as an introduction, explain a bit how Siemens Energy is actually using additive manufacturing and has been using additive manufacturing. So if we go to the first slide, I guess first of all, Siemens Energy is a bit of unconventional, I guess. We are living a dual business model. We are on the one hand side a user of additive, and we are at the same time a service provider to other industries via our materials solutions business. As a user, we have meanwhile more than 10 years, it's actually even 12 years, user experience with additive manufacturing, predominantly now powder bed fusion, and we have about 30 years even user experience with LMD. We have currently 60 qualified components that we have across our fleet in serial production for our gas turbines, steam turbines, generators, powder bed fusion. We have more than 300 qualified components that have been developed over the past on LMD. I guess we are one of the world leaders when it comes to proven field experience. We have 1,500,000 operating hours of additive components on our engine. So we have really proven and validated that technology in the field. And in order to do so, we have quite extensive material database because we are, in our case, the design authority that releases additive parts to our feed. And we have additive standalone 40 really people that do nothing else but additive, and we have about 200 people overall working in our additive organization as Siemens Energy. So I guess we've come quite a long way, And as Siemens Energy, we predominantly focus on using additive for our power generation business, EDF, one of our big customers, also our oil and gas business, and then of course also the transmission business. As a service provider, we acquired in 2016, we acquired Material Solutions, who has 14 years experience with high temperature metal additive manufacturing, founded in 2006. Material Solutions is working for a variety of different industries, predominantly aerospace, automotive, and tooling, plus, of course, Siemens Energy as a user. Material Solutions has multiple parts in serial production, fully aerospace qualified, and then, of course, also energy and oil and gas qualified, a broad range of materials, and overall more than 5,000 parts delivered predominantly from the early days still prototypes, but now I guess the number is actually now significantly higher ever since we entered into serial production. So a dual business model. If we go to the next slide, please. This is our footprint. We have currently 5 major locations where we do additive manufacturing, powder bed fusion, and we have multiple other industry footprints where we do LMD, where we do wire arc additive manufacturing, and where we do other manufacturing technologies. But we have 3 major facilities in Worcester, UK, the home of Material Solutions. We have a big site and focus area in Sweden, Finspång, where we do a lot of serial production and technology development for our oil and gas business. And we have a newly opened innovation center in Orlando. So there's the 3 core sites. We have 48 printers installed, powder bed fusion printers installed across our footprint today. More than 200 people working on AM, I said that before. And we have factory floor space, I guess, for more than 100 printers that we are currently working on to ramp up. And if we go to the last slide, that's a bit the story of how do we use now AM on the specific use case of our large gas turbines. We have multiple challenges on the product side and on the supply chain side. I guess we need to become more flexible in fuels to afford sustainable energy fuels. We need to reduce emissions, and we need to increase our combustion temperatures to drive efficiency and power output of our products. And on the supply chain side, we need to become faster in repair. We need to get faster to the market with new technologies. Spare part need to have accelerated availabilities. And all that together drives us to an additive strategy that we want to go from 2% of the value of one of our products is currently addressed by additive, and we are at the beginning of this journey. We want to increase that share over the next 3 years to over 20% of the value of a gas turbine being addressed by additive. And I guess we do that by working on rapid prototyping. We focus on rapid repairs that we basically can repair faster and more cost effectively, support our fleet with spare parts on demand. Then we talk about substitution of current parts. And then I guess what's really then the most value is we are designing very specifically for additive manufacturing as a technology. And that, of course, applies to large gas turbines as shown here on that slide, but it applies to our entire fleet of large and medium-sized gas turbines and steam turbines and generators. And with that, I'd like to stop and wrap up the discussion from our side. Thank you.
Thank you very much, Marcus, for this clear presentation. So we can see that there is a clear strategy for you to actually increase the use of additive manufacturing within your energy sector. We're going to end up the round of presentation with Jonathan Moulin from Vallourec. Jonathan, the floor is yours in order to briefly present us your activities with additive manufacturing.
Thank you. Thank you. So first, can you confirm me that you can see my screen?
We can see the screen and we can hear you properly.
Okay, so let's start the presentation. So guten Morgen, hello everybody. So I'm really happy to have been invited to talk about Vallourec activities in additive manufacturing. So yes, but I think you can see the presentation. Did I? Okay. So can you please confirm what you see, the presenter view or the general view?
This is the screen. It's okay.
The presenter view with the 2 slides. You need to swap.
Okay, thank you. Okay, sorry for that. So Yes, so to talk about Vallourec, so I don't know how many of you know this company, but this is a tubes and pipe supplier, mainly dealing with oil and gas market, so providing services and solutions for this business. So Vallourec has been active in additive manufacturing since 2016, so focusing on two technology, which are the thermal spray and the wire arc additive manufacturing that you can see here. So what is important is that the first step has been made to cover our internal needs, so to make the own tooling, and then of course to spread it to the market that we are serving. So here you can see, and this is a layer by layer metal deposit technology, where the mastery of the trajectories and the parameters are key. So as mentioned, so Vallourec is active mainly in oil and gas, so for the energy, but also to the several markets that I have listed here. So on line pipe, maritime, railway, process power generation, so like for EDF and Siemens, and also structure and agriculture. So now going to the main achievement. So I put here two examples. So the first picture, this is a crossover. So it's an accessory that is used on the rig for oil and gas application. So it has been made for an end user, a customer. And as you can see here, this is a part of 350 kilos that have been printed, then heat treated, and after thread on each side and machined. So what is important to keep here in mind is that the mastery of each step is important, and the key challenge for the industry, and especially when we talk about the end user and the adaptation of the technology, is to make the qualification of the material. So here, this is a carbon steel, but as it is AM printed, then it's considered almost like a new material. So we have performed a lot of tests to bring confidence to the end user. The second part, it's a smaller one, but just to illustrate that even with this carbon steel, we can withstand 2000 bars pressure test. And that test part, they are used, they are ready and available. So to be very short, what Vallourec is really trying to develop, and with the different partnerships, because this is a common effort to be done with the OEM, with the manufacturers, with the end users, and also with the third party, is to bring confidence to the industry. And the big point is to qualify the part and put the quality system that is needed so that the part can be validated and installed on the field. So for that, the expertise, thanks to the historical business, is about metallurgical development, non-destructive testing, because of course you need to test that. Also digital, so we talk more and more about digital library, and all of that need to be packed and discussed all together to make the big step with this technology. So that's it for me.
Thank you very much to the three of you. I think we all have a much clearer understanding of where you stand with additive manufacturing. Now we've planned on actually asking the question to you guys to where do you think additive manufacturing had the most important role to play in your specific industries. So to answer that, I'll start with Marcus. So Marcus, where do you think additive manufacturing had the most important role to play?
I am having a bit of audio issues. I don't know if that is now on my end. Can you hear me well?
We can hear you well, yes.
All right, thank you. Then I'll try. Thank you for the question. I think we are looking at additive from 4 different dimensions when we're looking at a role to play. Number one, additive helps us to meet, I guess the energy sector faces a really big challenge, which is this energy transition, from fossil fuels over time to a net zero carbon emissions target. and renewable technologies. So additive number one helps us to increase the efficiency of our current predominantly fossil-based gas turbines, and it helps us also to reduce emissions. So number one, it helps us to be a little bit more towards our net zero carbon target, because there is still, I guess, a bridging period that this whole industry will face until you can reach a net zero carbon target. So number one, efficiency and emissions. Number two, it helps us to further push the boundaries of, for instance, hydrogen as a fuel, then a real zero emissions fuel, because if you really want to burn hydrogen in a gas turbine, your whole combustion behavior and dynamics is different versus natural gas, and additive is a key technology to help us redesign burners to make it suitable for hydrogen combustion. And we have currently already customer projects where we have proven up to 60% hydrogen content in one of our smaller gas turbines, and we're working on a strategy now to really make our entire fleet over the next year hydrogen capable. So it unlocks new opportunities. And then there's, I guess, two more operational. It helps us also to increase the competitiveness of our current fleet, the installed base out there, by helping our customers to modernize equipment. And I guess EDF, one of the big and highly valued Siemens Energy customers, upgrades, modernization of the current fleet, also in terms of efficiency, in terms of lifetime extension, in terms of emission reduction. And number four, it helps us to also be a bit more efficient internally. We can reduce inventories because we have shorter lead times from an additive supply chain versus a casting supply chain. Those will be the four levers where we really see the big application areas where additive is playing a role for us as Siemens Energy.
Thank you very much, Marcus, for those. Jonathan, what is for you the most important role for IAM?
Yes, so if I focus on the oil and gas sector, for instance, so clearly there is a way to reduce the lead time. So it means to have the part only needed where it needed and in an accurate time. So, and this all that to reduce the total cost of ownership. So meaning you can reduce your stock and you purchase only when you need it. So this is one key feature. The other one already mentioned, this is also a way to limit the environmental impact. So for instance, so first during the production, and also as you can print closer to the point of use, you can achieve nice target on that.
All right, thank you very much, Jonathan. And last but not least, Yang, what is your point of view on that question?
Okay, so as said by Marcus and Jonathan, in fact, for us, our most important role is the obsolescence problem treating. Because with additive manufacturing, we can treat all these problems, which are the biggest problem for end user as EDF, and also we can repair our components for the maintenance, and then also for the quality, because we can use new materials with some gradient materials, for example, so we can try to get better performance of our stations.
All right, so we can see that actually there is lots of hope and actually future hopes for the use of additive manufacturing within your sectors. Now, we've already started talking with some of you already talked about a little about that question, but I wanted to know whether do you think that additive manufacturing can really help reducing the carbon footprint of the energy sector? Jonathan, you'll start.
Yeah, okay, sure. So if let's take an example. So if you remind the picture I just showed from the crossover, so used for the rig. So for this, so thanks to two things. First, the redesign. So clearly we put material only where it is needed. And second, that we add material instead of removing it compared to the traditional production route. Then we make the calculation and we could spare almost 50% of CO2 emission. So to give you a figure, 2.35 tons with the traditional route, and now with WAM 1.3. So it's 1 ton CO2 spared, and so it's not so much, but okay, it's a flight between Paris and New York, for instance. So yes, there is big sparing to be done.
Right. Thank you very much, Jonathan. Yang, what's your advice on that question and your opinion?
In fact, EDF, we are end user and we produce electricity, so we can make parts, components on demand. It's a very big advantage of the additive manufacturing. So we can produce on demand, we can produce locally, and we can reduce our stock. So we can do stock optimization. So all these points can reduce the carbon footprint in the industry for our maintenance, for our part, and also for the producing of electricity.
All right, thank you, Yang. And Marcus, your turn. You've already talked about it earlier on, but maybe you have more to add.
I guess it clearly does. I mean, there needs to be, of course, more in place than just additive manufacturing, but I guess it is. I guess for me, from two dimensions. It helps us to reduce emissions on our current fossil natural gas-based product lines. So basically, you can through better mixing of natural gas and air when you do combustion, you can significantly reduce your CO2 and NOx emissions in our current fleet. So that is, I guess, still not fully green energy, but it is a bit greener than pure conventional. So additive really helps there, and we see about a 30% reduction potential for greenhouse gas emissions through additive on our current fleet. And I guess the big step then will come when we can potentially even really go to 100% hydrogen as a fuel on gas turbines, because then you are by definition zero carbon emissions. And I guess the third element would be, if we're looking into our future decarbonization fields where we are looking, then additive also might help us to unlock some of the design spaces there in order to bring new technologies to the market, which then make it to the market eventually more environmentally friendly or economic advantageously. So I guess those three dimensions would be my net zero carbon emission contribution from additive.
All right. So actually, yeah, we can see that using the technology may actually help us to bring down this carbon footprint. Now when we exchanged earlier on, we wanted as well to discuss on the developments needed, developments that are needed in additive manufacturing in order to further drive the adoption of additive manufacturing within the energy sector. The idea is, of course, to increase the confidence of end users. What is, Yang, your point of view on that question?
Okay, so just EDF, we are not manufacturer, we are end user. So by using additive manufacturing, if you want to use it in our industry, the first question we must to treat is the qualification. The qualification of components versus regulators' requirements. And also for the standard and codes, we need something in the standards and in codes, so we can be guided in our industry. And some now we have some technical barriers. For example, first with the material, so reverse engineering, we must have the confidence on the reverse engineering versus the design optimization, and also complex geometry, how to treat them, how to optimize our structure, our designs. And secondly, the in-service properties. For example, the fatigue, the corrosion, the post-treatment, the residual stress, the anisotropy, the creep, the wear. So all these in-service properties must to be guaranteed for us to use all these additive manufacturing components. And thirdly, the process control. We must to know how to do the control during the manufacturing, after manufacturing, and also in service. So how to do the NDT, non-destructive testing during in-service. So we must know all these points to have the confidence of the additive manufacturing component.
All right, and you already have answers on most of these points, or is it really all of those points that needs to be addressed in the future?
We have some answers for these questions, but we have no answer for everything. So we are working with everybody. We are working with with Vallourec. We are working in Additive Factory Hub. We also want to work with Siemens to treat all these problems in order to introduce additive manufacturing as a traditional manufacturing process in the industry.
Okay, so we can say that we have actually a panel that actually work all together.
Yeah.
Right now, Marcus, what is your point of view on that question?
I guess for me, additive now going forward and how it can play a further, even taking it from the angle how it can play a bigger role actually even going forward in energy that it plays today. I guess we talk a lot about what do we need to further do in order to increase the adoption of additive throughout our product lines, and how do we then need to talk about industrialization. So I guess those for me would be the two big things of how to can you looking at it from the angle of how can you maximize the use of additive. And when we are talking adoption, I guess you have a challenge that the current technology still faces in some instances hurdles of not being cost competitive to current established technology. So even though, as Yang said, there is real big advantages. Yeah, you have faster lead times, you can reduce your carbon footprint, you can reduce inventory, so no one questions that. But then what we still need to work on from a pure technology side is we need to further work on the industrialization of the technology. We need to make the processes more repeatable, that we can trust the quality, because we would only put end-use parts on our products that we then basically sell to EDF if we trust the technology. So we need to, first of all, I guess, learn a bit more about the technology and gain more experience. Secondly, we need to learn how to do this technology in real serial production, because if you're really serious about additive, you do not only want to make one-off prototypes. I guess we can do that. We've proven that. We now need to show that we can do it in repeated quantities and full swing serial production, because if a customer like EDF or others have gas turbines operating, they need spare parts, they want upgrades. There is no, then you're all of a sudden, you're really in production. So this is the second. And the third is we need to continue to work on the cost side of additive. And if those three things, I guess, are being further driven very hard, then I think it can play an even more important role in the energy sector as it is playing today already. It's eventually a more technology-driven answer to the question, but that's at least what's keeping us focused these days. Yeah, those three elements.
Yeah, but it is true that it is. Those are elements we actually hear across many industries. Actually, Jonathan, your last on that question.
Yeah, so I do completely agree with what has just been said. So going from R&D to real industrialization is a big gap. So demonstrators can be done, but how can you say that this demonstrator is representative of the mass production? So what type of size are we talking? So, and of course, it was mentioned, many tests has to be performed. And when we are performing these tests, it costs money. So at the end, who is paying for the qualification? So should it be the end user? Should it be the manufacturer? So who? And somehow data has to be shared, because everybody cannot develop its own prototype in its corner. So this is why I think it's a new way to collaborate, and I think it's a good example today on this panel. But clearly, if there is no strong partnership with all the parties, I think it would be very difficult to deliver the promise, as mentioned by Marcus, of fast delivery time, reduce cost. So it's absolutely key. So this is for say the economical point of view and business. And it was also mentioned by Yang, what is very important and what will make the change, I think, for the adoption, it will be when the big standards, so API, ASME, and so on, will deliver the first norms. So because for the people that are not so well aware of this technology, it will be a release. Okay, so if I'm following this procedure, then I can be sure that I will have some type of quality. And it will be a major step, I think, for, let's say, the adoption on a wider scope of this technology. And it's happening now.
All right. Thank you very much for that. So we've heard again the need for exchange actually in collaboration. So we can only incitate every actor, of course, within the limits of confidentiality, but every actor to share their work and results and collaborate in order to go further and quicker with the technology. All right. Now I remind to people as well, to the audience, that if they wish to ask questions, they can do so. We have a last question, and then you will be able to have your question answered. So I wanted to know as well, to what extent did the pandemic impact additive manufacturing in your sector? Marcus, you go first.
I guess the pandemic, of course, had an impact on I guess almost every industry. I guess in comparison, I guess since we are working through material solutions, we are also working for other industries outside the energy sector. Yeah, for instance, aerospace. And if we compare the impact that the pandemic had on us in additive from the energy side versus on us in additive from the aerospace side, aerospace, and we all know that, yeah, has been severely impacted by additive. And I guess what we see also that our customers on the aerospace side, not only do we see that there is less demand for serial production parts in additive, there's also a big stop and pause on investing R&D budgets in a new technology like additive, because you just have the big cash flow constraint currently in an industry like aerospace. So I guess there's almost a pause on everything for the last 12 months, and we slightly see this coming back. On the energy side, it's a bit different for us, because I guess we had before Corona, we already had this big shift of decarbonization as the future trend that is changing an entire industry, and we see that fossil-based power generation is actually not your number one growth sector anymore in the energy sector. It's really the renewables that have been picking up speed a lot faster than we anticipated, and they are growing a lot faster than the fossil technology is still growing, but it's moderately growing. So what we still see on the energy side, we are really we already started to adjust to the new reality before COVID hit, because it was driven by this massive shift in the energy sector. And what that has done to us in Siemens Energy, speaking on this as well, we had started 2 to 3 years ago to really put a lot of focus on what can additive do in order to help prepare that transition of the energy sector. And so while, of course, Corona had an impact on our business, yeah, no business goes untouched through Corona except you are Netflix or food delivery, then I guess you might have seen an opposite effect. But no industrial business has gone through the pandemic untouched. So we have seen an impact. But since we had already focused on how can additive really drive efficiency, emissions, and operational efficiencies before the pandemic hit, we pretty much worked through the pandemic on the additive level pretty much stable, because we had been working on the right topics that have been even more relevant through the pandemic. And luckily, Siemens Energy as a company overall could also still afford to continue to invest in additive. So we have not seen a negative impact on the additive level from the pandemic. We actually have even seen an even stronger pull for faster bringing technologies to the market, which help us meet our journey goals towards net carbon emissions even faster.
All right, thank you, Marcus. For the food delivery, we start printing food, so maybe in a few years you'll be able to have food delivered to your door. Thanks for the input, Jonathan. Do you stand on the same foot? What did you?
Yeah. Actually, I have to admit that clearly things have changed, and the example I have in mind, so it's coming from the oil and gas business. But for instance, due to the pandemic, so the traffic between the countries has stopped. So it has become more and more difficult to get some parts from a faraway country. So because of borders issue, because of stop of flight, and so on. So what it means is that I think there is a conscious that has come to say, okay, let's get the part locally. It has major advantages. First, I'm not dependent from this traffic, so and so on. I'm reducing the CO2 impact of the transportation, and I have to source locally. And additive manufacturing, with for example the WAM I'm talking about, is not a big capital expenditure. So it means you can print not so far from the point of use. And clearly, for major operators, they say, okay, so in this case, it's interesting to have this local production tool, because then it reduces the risk if a new pandemic is happening. So I think it can, and as Marcus said, it can accelerate this transition to a more local, easier communication, especially if we want to talk about the quality. Maybe it cannot be perfect at the first row. So maybe, let's say, look again what is happening close to where I'm producing. And I think that this discussion today, so for France and Germany, so with our company based in both sides of the Rhine, is interesting to say, okay, can we have a look at what I can source? Not so far from where I am having my activities. So
So yeah, change in mindset and maybe
yes,
accelerating those mindsets about additive manufacturing
and this is something we see with major with some operators in the oil and gas industry. Yeah.
Of course, yeah, which will go as well within bringing back some of the production locally and close, as you said, to the consumer. Yang, your advice on the question?
Yeah, I totally agree with Marcus and Renatan. In fact, everybody is impacted by the pandemic. EDF is also very impacted. But if we focus on the use of additive manufacturing in our sector, due to the after the pandemic, in fact, I agree with you. We are just accelerating the adoption of the additive manufacturing, because I remember that last year I have seen some plastic masks printed by 3D printing process. And why? Because we can produce locally and with a very short lead time, and also with a cost which is okay. So we can use additive manufacturing. We are making the transformation in our sector, and just because of that we can use the advantage of the in terms of cost, lead time, and quality of the additive manufacturing. So I think that the pandemic just accelerate the adoption of additive manufacturing in our sector.
All right, thank you very much, and thank you to the three of us for that panel. Julie, did we receive any questions for our speakers today?
Yes, we did. We'll try to keep it short. Maybe I would like to begin with a question for EDF, for you, Mr. Chen, from Alain Bernard from the proeminent engineering school, École Centrale Nantes. Are you confident only in WAM? What are your capacity? Are you planning to build up some facilities close to your production units? And maybe connected to this question, another one from Bertrand Maillon. What is your target in terms of stock reduction?
Okay, so we are, as I said, we are not manufacturing. We are end users. So we are not installed. We will not install the additive manufacturing facility in our nuclear centers, for example, or our hydraulic power centers, because we are not. We need to. We have some supply chain here in France and in Germany, and we can use their experiences on the manufacturing of the pieces. But for repair is different, because we need to repair in our stations. So we need our suppliers, for example, Siemens or others, to come to our nuclear centers, hydraulic power centers, to repair inside of our plant. So it is different from repair, additive manufacturing repair, and additive manufacturing for spare parts.
All right, thank you, Julie. Any more questions?
Yeah, maybe a concluding question, like Mr. Moulin and Mr. Shin just mentioned. How do our speakers manage the production with AM on different sites? Maybe here in Europe. A comment maybe on that, Mr. Seibel, you didn't mention it.
Say it again, please. Can you explain it? Can you repeat, please?
How do our speakers manage the production with AM on different sites?
How do we manage that?
Yeah, on different sites.
Okay, sorry. Apologies. Yeah, thank you. So I guess that is still a challenge. I guess what we try to do is, I guess if I think about this now, how we are addressing this, it's basically three things that we are trying to do. A, we are trying to standardize, first of all, equipment. That because we have usually a lead side that is taking a lead on developing the technology and then doing all the real detailed characterization work of the material, of the printer, so that we then can really qualify and certify a part. So we have a lead side, and then we try to standardize equipment across different sites. But that is actually already a challenge itself, because sometimes, even though the printers are formally identical, they are not when it comes to detailed software configurations, etc. So I guess standardization of equipment is one thing. A second thing we are doing is we are learning while we go. So we do learn how to qualify our products. Of course, you have specifications that we need to meet, and then we have engineering teams that need to develop processes that meet those specifications. So what we are trying to do is we learn how to transfer qualifications. So we qualify a part in one of our centers, and then we try to transfer that qualification into one of our serial production sites. And this is not going seamless, and we are learning this basically, and we are writing then very specific specifications how to transfer processes from one side to the other one. Number two, and number three actually is a bit. We are also trying to somehow focus our different sites on certain core competencies. Yeah, we might have a core site where we have our expertise for our high temperature materials, and then we have another site where we have our core expertise, for instance, for lightweight materials, so that we're not trying to do everything everywhere. But I guess the core is still the topic number one. We need to make sure that we understand how equipment compares to each other, that we understand configurations of the equipment today, and that we then have specifications that we actually understand how to transfer from one location to the other one. Yeah, that would be my first question. But it is still one of the open challenges that companies like us still need to work through. This is not solved yet.
All right, thank you very much for all those answers. Jonathan would like to add some points.
Just a quick word on that. So clearly, so because this is a question of the distribution production network. So clearly, once a part is qualified, how I am sure that if it printed at another point of use, it will be okay. So this is a challenge of the digital chain. So the answer for that is, okay, how we will manage the data to ensure that we are reaching the quality of the part at the end. And as Marcus said, this is a big challenge, and that is currently being investigated in the industry, and for which there was also a joint industrial project running to see, okay, how we can standardize this communication and put it in a digital library, for instance. That's my comment.
There are companies as well working on both sides of the Rhine on those problematics indeed.
Exactly.
Jan, would you like to address something on that question?
Yes, because as we have some sites where we have 56 nuclear power stations. We have more than 400 hydraulic power stations. So how to share the experiences of the additive manufacturing in one site and then expound to other sites? It's a real question. And then we are establishing, as Jonathan said, a digital library, so that we can share experiences with other sites, and then share the qualification of the parts and also the CAD of the parts. So it's a very interesting question. And then we must secure this digital library. Also, this is a big issue.
Yes, so there are still questions to answer in every level, actually, materials, technologies, digital, etc. But I'm sure with all the efforts put together by decision makers, OEMs, as well as innovators. We are reaching the targets, and we'll do pretty soon. Thank you again, guys, for sharing these information and taking the time to be with us this morning. We'll let you go. I'm sure if people have questions, they'll be able to find you as well on professional networks. So for now, wish you all a good day and look forward to meeting with you very soon again.
Bye-bye. Thank you.
Bye-bye.
Thank you.
Thanks. So for us, it's going to be time to jump to the second pitch session. So once again, 5-minute pitches by 3 companies from across the Rhine. We'll start right now with Rainer Beckhardt from Lenovo, who will actually present us his company and innovation. Rainer, it is for you to go. You have 5 minutes. Currently, Rainer, we don't hear you, so maybe your microphone is not on.
Can you hear me now?
We can hear you now. Go ahead.
And hopefully you can also see me.
We can see you as well.
Yes. Can you see my presentation as well?
Everything's working fine.
That's great. So first of all, thank you very much. I'm not Rainer Beckhardt, I'm Lars Böske. I'm the proxy today for this presentation. So yes, I would like to welcome you on behalf of Lenovo. As I said, I'm Lars Böske. I'm one of the managing directors of Lenovo. Yes, and today I would like to introduce our company, and I would like to introduce our technology.
Rainer, unfortunately, we cannot hear you. Is there a problem or a button on your microphone or anything that could block the sound?
Okay, yes, I was muted. Can you hear me now?
Yeah, we can hear you now.
Okay, I'm sorry. So I start from the beginning, okay?
Start from the beginning. Just for information, I'll just pop up this thing. We'll launch the video directly from our side, all right? That way you don't have to worry about it.
That's great. Okay, that's great. So we were founded in 2013. We are a spin-off company from the Fraunhofer Institute here in Aix-la-Chapelle or in Aachen in Germany. And currently we have about 22 employees. So we are focused on building laser machines, predominantly for additive manufacturing, but also for microprocessing. We have an own in-house process development. We have an LMD or DED application center. And yes, about 40% of our staff has a software development and information technology background. So our customers are based mainly in Germany and in the European Union, but we also have a couple of customers in France so far. So what is our technology and what is the added value? So the most important thing is there's no need to generate CNC code for our machines. It means there is no need for manual programming, and that will save a lot of time, as I will show you later. Yes, how do we achieve that? We achieve that by integrating a scanning technology into our machines, so we can carry out LMD processes on 3-dimensional parts without having any CAD data. And an application for that is, for instance, the repair of 3D parts. But we are also able to print 3D parts on existing 3D parts. That's very interesting. And further, it is possible to code parts, and I would like to show you an example for that. So this is the setup for my example. So you see an excavator tooth, that's the workpiece, And here you can see the powder nozzle and the optics, and the line scanner. So the scanning line, you can see there, this blue line. And when we move this line along the workpiece surface, we can create a 3D scan. And now I would like to ask you to show the video.
Yes, we can unfortunately not hear you while you're commenting the video.
I'm sorry. So yes, we have here this excavator tooth, the workpiece, and now you can see how the scans are carried out. You can see the moving lines, and here you can see the digital twin. That means we have recalculated the part in our software, and now you can see how these tool passes are generated automatically. That means we have the possibility to create the tool passes. And in the next step here, you can see how in a simulation it looks like. So it is possible to check if everything is running properly or if there are collisions or something like that. And after it is fine with the simulation, we can directly step over to the execution of the real processing, the workpiece. So we have speeded up here a little bit, but as you can see, now you have, yes, we have a nice coating of our excavator tooth that is carried out now. And yes, all carried out very quickly and with a good result. Voila. Okay, so actually we can now go back to my presentation. Okay, I hope you can see it. I transfer my screen.
We can, the presentation is coming up right now.
Great. So this is just a short summary. So what we saw is that is the time from the very first scan to the start of the processing just took us 4 minutes. So it's really a short time. As I said, we did not carry out any NC programming. We did not carry out any teach-in, and we had no CAD data of the workpiece in advance. And yes, of course, this application can be used or it can be applied to other topics, but with the same way how to proceed. Okay, thank you very much. So I'm looking forward to getting in contact with you, and if you have further questions, I would appreciate to answer them.
Thank you very much, Lars. Yes, indeed. If any questions, please add them in the chat, and we'll have a Q&A session at the end of the pitches. Thank you again, Lars. We'll jump right now to Philipp Schwarz from Rosbach. Philipp, the floor is yours for 5 minutes.
Thank you. I hope you can see the screen, the presentation now. Perfect.
We can see and hear you very properly.
Perfect. Yeah, good morning, everyone. I'm happy to be here today. Unfortunately, not in Paris, but at least virtually. And my name is Philipp Schwarz. I'm a project manager at Rosbach Engineering and responsible for customer projects, as well as some public funded research projects dealing with high-end applications and new alloys for laser powder bed fusion. So Rosbach Engineering, with its 12 employees, is part of the Rosbach GmbH with nearly 200 employees. So we are a middle-sized company, and dealing in the open die forging business since 1911. And for example, we are forging parts for nuclear or gas power plants or the semiconductor industry. And since 2014, we at Rostwag are fully focused on a holistic process chain for laser powder bed fusion. We are a service provider. Let me just go to the next slide. Exactly, so we're a service provider printing prototypes and serious application for our customers. And yeah, what's the USP, I would say, from Rostwag, from our company, is that we are very small size, but have a holistic process chain for metal AM in-house. So of course, we start with engineering and simulation services. We can simulate the whole process, but also CFD and FEM simulations for the design and the development of new parts. And what's really special is that we have a small size atomizer for our powder production, and we can produce small amounts of new or special alloys between 5 and 50 kilogram economically, especially interesting for research institutes or for the qualification of new alloys. And of course, we have a laser powder bed fusion process in-house with machines from SLM Solutions, as well as different post-processing steps like heat treatment, CNC finishing, and a fully equipped metal laboratory to see how's the porosity, how's the mechanical composition of the parts of the powder, how are the mechanical properties and things like that. We are certified from TÜV Süd for the additive manufacturing process itself as additive manufacturer, but also to produce high quality metal AM powders on our own atomizer. I would like to show you some applications. Here you can see a guide vane cluster for gas turbines of MAN Energy Solutions. It was one of the first AM applications for the energy market, and Rostwag is here one of the 2 certified providers for these parts to produce out of Inconel 718. Another cool thing is cooling application for tooling, turning tools. We patented this tool with several cooling channels for the very effective cooling of the tooling insert. We can increase tool life up to 40% compared to conventional cooling. And that's a real serial application with several thousand parts each year. And yeah, we're not only printing parts for customers, we're also doing material qualifications as a service. For example, if we are producing a powder batch, go on the SLM machine and make parameter studies and printing porosity cubes, tensile bars, and things like that. And then we can go from the pre-material to the first results of mechanical properties in 4 to 6 weeks. So we have that initial qualification of a new alloy fully done. And then, of course, it goes to a further prototyping and validation to reach higher technology readiness level for these materials. And with the services, we have a very unique material portfolio for laser powder bed fusion. We qualified over 35 materials in a couple of the last years. And of course, they are some initial qualified materials, but also very large amount of materials which are ready for serious production, like 316L or an M300. So thank you very much for this possibility to speak here. If you have further interest in some services of us, please feel free to contact me. Thank you.
Thank you very much, Philippe, for that presentation. And Yes, you're right. If any questions, please feel free to add them on the chat. We are going to go now to the last pitch of the morning, and we'll welcome Yannick Wilkens from the SMS Group to present his company and technologies and innovations. Yannick, it is for you for 5 minutes.
Yeah, hello. Can you see my screen and can you hear me?
We can see the screen and hear you perfectly.
Perfect. So yeah, good morning and welcome. My name is Yannick Wilkens, and yeah, I'm happy to be here today. And yeah, within the next minutes, I will briefly introduce our company, SMS Group, and our technology, which refers to additive manufacturing. So SMS Group, yeah, is a plant supplier, is yeah, a worldwide leading partner to the metallurgical industry. And with our products and brands, we cover the complete value chain in this metallurgical sector. SMS Group is a family-owned business with 150 years of experience this year and around 14,000 colleagues around the world. But let's go directly into additive manufacturing. So the additive manufacturing activities at SMS Group started some years ago, where we set up a 3D competence center in Mönchengladbach here in Germany. And this covers the complete value chain. We have a pilot plant for metal powder production here in Mönchengladbach. And this yeah, metal powder plant is one of our products we sell to our customers as a plant supplier. And I will introduce these powder plants on the next slides. And what we do secondly is we also do redesign and 3D printing of parts for yeah, internal reasons, for installation at our customers as parts of the plants or spare parts. Yeah, just to give you an overview about our powder plant technology to produce these metal powders. So we offer equipment for gas atomization with and without vacuum, and also for reactive materials as aluminum. And in addition, we also sell plants for water atomization. But today, I will have the focus on our core product in this field. It's a VIGA plant, so the vacuum induction gas atomization technology. Gas atomization means that the atomization process of the metal powder is under gas stream, nitrogen or argon gas, and the vacuum, as the melting is under vacuum, to guarantee highest quality of the material, the metal powder, which is produced with our plants. And as you know, in additive manufacturing, you have higher quality requirements for the powders, and therefore you need, or you will need, such sophisticated plant. On the left side, you can see a picture of our pilot plant. So this plant is an industrial scale plant with large dimensions of 16 meters each, but we also do smaller plants. And one of our latest references I can talk about is that we sold a plant a few months ago to Outokumpu. Outokumpu is a leading stainless steel producer, and this plant has an annual capacity for powder production of 330 tons of powder, metal powder. And on the next slides, I will talk about the plant technology and the innovative business model we sold to Outokumpu. So the technical and commercial advantages of the SMS powder plant technology can be summarized in, let's say, 4 core competences. So at first, our plants produce the most advanced powders you can find. That means the gas atomized powders with highest qualities. And you can see one of our powder in the microscope picture on the right side, where you can see the morphology of the powder. So the particles are really round and have a high sphericity. So you can see that the technology produces high quality powders. The second point is that we have a really high yield of AM powders due to our own nozzle design and hot gas atomization. Our technology has a high efficiency of production because it's a large industrial scale plant. And we also offer highest flexibility to our customers. So we have a large range of alloys you can produce. You can change the crucible. You can easily clean the system. Yeah, and these are the 4 main advantages. But last but not least, I would like to present you another unique selling point of our technology or our plant business. And this is the business model itself. So we offer our equipment as a service. That means it is a subscription contract. So you don't own a product. Instead, you rent it over a longer period of time. And you know this contracts from leasing of cars, for example. But for metallurgical plants, this is completely innovative. And in this contract model, you do not own the plant, as I said, but you will pay per ton or kilogram of produced powder, meaning you only pay if the plant is producing, if the plant is running. So SMS will take care of the plant, will take care of the surveys, and therefore the technical risk is eliminated for the customer. So the customer has no high investment volume, there's no capex requirements, which lowers the risks. And of course, the risk to go into new markets, into new technologies is also minimized with this business model we offer. Yeah, that was a real quick overview. Thank you for your attention. And if you have questions or if you would like to have further information, yeah, feel free to contact me. Thanks.
Thank you very much, Yannick, for this presentation. Now I can invite you all 3, Lars, Philippe, and Yannick, to have your camera turned on for the question part. Julie, I do believe you've received questions for our teachers. Julie, are you with us? Maybe just a little delay in the technique. Maybe. Oh.
Hey, here's Julie. I needed to switch computer. My screen was frozen. I take the questions. One moment. So my first question will be for Lenovo. What customer pain does the tooth coating case study solve? Is there a true economical benefit? Would you like me to repeat?
Yeah, your microphone is off, Lars.
I'm sorry.
Was it clear? Should I repeat?
Please, I'm not sure if I understood it correctly.
What customer pain does the tooth coating case study solve? Is there a true economical benefit?
Yes, of course, because for instance, the repair applications deliver the opportunity, yes, to use the used parts more, not to build new ones, and this is a very big advantage for our customers to save money.
Okay, maybe another question for Rostbach this time. Hello, what material did you use for conformal cooling?
It's a M300 tooling steel for the turning tools. We have other applications for toolings, which we are using new alloys with a higher hardness, but for this application, it's enough to use the M300.
All right, if we still have time, I would have 2 questions more. Is it okay, Guillaume?
Yes, it is okay. We still have 3 minutes.
Perfect. And another question for Rosbach would be, what are your typical customers for your metal 3D services?
Yeah, so for that material qualification business. It's more OEMs in South Germany, automotive customers or tier ones in the automotive area. And for serial application and prototyping, it's more or less everything. We're doing a lot of for tooling companies, but also for the semiconductor industry or automotive.
All right, thank you very much. And the last question for Mr. Boske will be from my side. How large work PCs can be machined with your technology?
So actually, there's no limitation because yes, we have the possibility to deliver our powder to every point and to make the axis as long as we need. So there's no limitations because we do not have a chamber or something like that.
Okay, that will be all from my side. Thank you very much.
All right, thank you very much, Philippe. Thank you to the three of you, Philippe, Yannick, and Lars. I'll let you go to your occupation. I think you'll be back this afternoon as well for the B2B meeting session. But in the meantime, thanks again and good end of morning. We'll now jump to the last panel of the morning. Last but not least, of course, we'll now talk about mobility and see to what extent its future can include additive manufacturing. Now, for this panel, we'll welcome on stage three high-level speakers. We'll start with Stefanie Brickwedde. So Stefanie is head of additive manufacturing at Deutsche Bahn and mobility Goes Additive. Hello, Stefanie. Thank you for being with us.
Hi, hello.
With you on the stand, we welcome as well Martin Bock. Martin is head of the Metal 3D Printing Center at Audi AG. Hello, Martin. We cannot hear you, Martin. Maybe your sound is out.
Check.
Yeah, we can hear you now. Hello.
Yes, all right. Hello.
And with you both on the stand, on the floor is going to be Fernando Bonilla. Fernando is materials and cutting expert at Renault. Hello, Fernando. How do you do?
Hello. Good morning.
So the three of you are going as well to present briefly your company and the use of additive manufacturing within your specific industry. And we'll start with that with Stefanie Brickwedde. Stefanie, could you tell us how you use additive manufacturing within Deutsche Bahn and mobility Goes Additive, and tell us a bit about the best cases and best applications you have within your group.
Of course, it's a pleasure. Thank you very much. So then let's get started with the next slide, please. So what do railways use additive manufacturing for? They want to become more reliable. They want to be in time, but sometimes we wait for spare parts up to 2 years. So you can imagine that is also one cause for delays. And on the next slide, we can see what are typical examples for spare parts. So sometimes we just have to print small items of components. This is a very beautiful example of a window wiper water tank cover, and just a simple part which sometimes gets lost. But of course, such a locomotive can't go on the tracks without a working window wiper. And this is what we needed for. Before we had to replace the whole component. This is not necessary anymore. Next slide, please. So coming to the a bit bigger parts in additive manufacturing, we also print huge metal parts made with the technology which is called wire arc additive manufacturing. And therefore we print safety relevant parts. So this is linked to an ICE high-speed train, which goes more than 350 kilometers per hour. And of course, that part needs to be tested, which we can see on the next slide. So we have to take a real close look on the quality of such parts. And how we do this, you see on the next slide. So here we put it on a test stand and we simulated another 30 years of operation. We just needed for a couple, like 5 to 8 years. But now we really know that this part is definitely working and can be used for safety relevant parts. Next slide, please. I brought you a little overview. What are the main potentials for rail? So we secure a higher availability of parts in general. So at the end of a life cycle of a train or infrastructure, parts are often missing. So we talk about 25 up to 45 years of operation. And of course, no one can really assume exactly how many parts they would need at the end of the life cycle. This is when additive manufacturing comes in for small lot sizes. And I've already shown you another example for the partial substitution, so just a part of a component which is replaced. Now we have a solution for obsolescence problems when we can't get the parts at the markets anymore. We even have some experience with functional integration, and we often produce from lot size 1, so just 1 or up to 50 parts which are missing. Sometimes we even can reduce manufacturing costs. This is a beautiful example. It's a handrail sign for blind people. And we do individual solutions, especially when it comes to tools in the maintenance workshops. Next slide, please. Bionic structures are not usually the main focus of railways, but of course, as I already described, they have to secure the quality of their suppliers. And railways in Europe usually do not produce on their own. So they rely nearly to 100% on printing service bureaus. And therefore, we've designed an audit in cooperation with a certification body, which is the TÜV Süd, to secure that level of standards. Next slide, please. And because it's much easier to do this not alone, we've initiated, and now you have to click some more times, a network which is called Mobility Goes Additive, where you can find a lot of users from automotive, from rail, and other branches, automation, and meanwhile even medical. And we have all the big machining producers, material providers, consultancies, university institutes, and many more on board. So founded 4 years ago, we now have more than 130 members. Next slide, please. And if you should be interested to join us and work together on standards, on materials, on technologies, and bridging the gap between suppliers and users, you're more than welcome to join us. And on the next slide, you can find my contacts. Thank you so much.
Thank you very much, Stephanie, for this great presentation. Another example of the importance of collaboration with Mobility Goes Additive. So I can only ask, or not ask, but push people in France to do the same, because I think as well as you do that, it is really important to collaborate in order to move further and quicker within the adoption and development of additive manufacturing. Thanks again.
And you can. So,
yes, go ahead, go ahead.
Sorry for interrupting you, Guillaume. You can even join Mobility Goes Additive since it's an international network. So very open to French companies.
All right. Thank you for the precision.
Good. Well, first of all, thank you for inviting us to this very good webinar and conference. Let me just 2 words about myself. Fernando Bonilla. I'm an expert in materials and coatings for Renault for the production engineering division. And as such, I'm responsible to develop the additive manufacturing activity in my division. I also co-lead what we call additive manufacturing chantier expertise in our group, where our job mainly is to promote this family of technologies to help identify different applications and to share best practices, amongst other things. So if you could please go to the next slide. well, in my case, I included 2 slides, hopefully complementary to what Mr. Bug said for our view. So first of all, a little bit about Renault's experience, or what we have done with additive manufacturing so far. So mainly mock-ups and prototyping and process tooling. So yes, there's a lot of work to be done, but we have now a little bit more than a decade experience in the part of rapid prototyping and process tooling. And we covered, we are users, but we also produce some of our parts. We do not have, of course, all the technologies in-house, but we have now nearly 180 3D printers, most of them polymers, most of them extrusion type, DMFFF, but we also have some powder-based ones, about 35. Recently, last year, we installed our 2 new metal 3D printers, one BMD and another powder bed fusion with laser. And with which last year we produced a little bit more than 80,000 parts. Yeah. I allowed myself just pictorically, as schematically, to use the very nice chart from 3D Hubs to indicate in yellow the technologies that we have in-house, not seen very clearly in green those technologies that we often use externally. So, but then again, we make some parts internally, and some others we externalize them. So far, as I said, mainly we have used 3D printing for mock-ups, prototyping, and process tooling, and so far we have not introduced 3D parts in our vehicles directly, exception made, of course, for F1. But we are working strongly to do it in the near future. So if you could please go to next slide. And then what I did was to add very briefly the challenges that we have been confronted with and we are still going through, and some opportunities. These are just examples because the list can be quite long. So we have cultural challenges in such a big company like ours. So, you know, on the one hand, promoting these technologies, explaining what can be the potential benefits in front of very highly experienced engineers, which sometimes they can be reluctant to adopt new ways of doing things because they have seen many technologies in their lives. And on the other hand, being cautious because we are aware of the challenges. And in that case, it's more in front of the very young engineers that need or would like to change things very, very quickly. So that compromise is sometimes difficult to reach. At a different level, we have also a challenge an organizational level. We in Renault additive manufacturing activities developed like local fab labs to respond to local needs and very dynamic. Progressively and gradually, I felt that we needed to coordinate all this activity for many different reasons, because we needed to optimize the use of the different means, to share best practices, and to define an overall strategy. And that is hard work. That is another important challenge. Then going more through the technical part, when trying to carry out or to print the parts in-house, HSE has been a big deal, especially for the powder-related technologies, but not only. And of course, we know there's the development of new standards that would be of great help. But certainly, HSE aspect consideration, understanding the risk, understanding the preventive measures have been something that has impacted our project planning and sometimes investment plan. And finally, well, 4 and 5, what I have indicated as 4 and 5, which is somewhat related, but there are some subtleness between the two, has already been mentioned, is the part of validation of the coupled processes and materials. And this is valid whether we externalize the part or if we do it internally. As an example, in the case of externalization of parts, yes, of course, we know the people have done great jobs. And I put as an example work that I found on the internet where they compared, I believe, the fatigue properties of an aluminum alloy 6062. But that's a process that takes time. Yeah? And when trying to compete internally as an additive manufacturing guy internally against a traditional solution, it's always difficult time-wise, yes, to fit, to propose, to introduce the solution within the time frame of the project. And that is the first part. Then the other part, which is even the biggest part, is, okay, what about guaranteeing the properties for serious production? And there is where we have found some blockage in the past. Many suppliers, either they are not willing to do it, or simply they cannot, they don't have the capacity to do it. So these, I'm not saying this is a blockage point, but this is something that has certainly slowed down the development and utilization of additive manufacturing internally. And then repeatability, especially for dynamic properties. And going to the opportunities, 2 examples of opportunities, I think there is additive manufacturing has a great place, a great role to play, because we believe in the trend toward increased diversity for urban mobility. So as an example, we have worked and we are working on a fully personalized accessories like seat cushions, or in a more technical side, in order, as Mr. Bauger referred to previously, to reduce the investment on expensive tooling, especially for small series, then thinking about the structural assembly joints specific for that small series that will optimize and consolidate assembly with addition of function and more. I have to say that for us, for this type of application I just mentioned before, the economical equation is yet to be proven. We are working on that, and that is one. But it's a great opportunity for the future. And the other example I would like to mention is related to our big project refactory in Flan, and more specifically to what we think will be the increasing responsibility of auto manufacturers in the vehicle's lifespan extension. So we believe additive manufacturing for reconditioning and sometimes retrofitting autos have a very special role to play. Even so more, of course, if we manage to use recyclable materials. I'm of course thinking about polymer AM. And for spare parts production, already said before, it's a great opportunity as well. Thank you very much. That's all for me.
Thank you very much, Fernando, for these explanations. So yeah, the subject about safety has been raised several times. We'll jump to that afterwards. Even though the question's already been a bit answered, I wanted to ask you all, since mobility is an aggregate of several numerous industries, what is for you the greatest potential of using additive manufacturing in yours? So I know it's already been evoked a little during the presentation, but in depth, could you tell us more about that? We'll start with Martin.
Well, yes, I see the greatest potential right now for us, because we are manufacturing these internally, because we have this know-how developed over the last years. These are the conformal cooled tooling inserts, also jigs and features for enhancing the production methods and processes. Part development process, of course, spare parts, prototyping, that's more or less technology we set it up by deliverers, also by us a little bit. We develop new parameters for faster printing processes, of course, but I see the biggest potential right now today in these conformal cooled tool inserts.
All right, thank you very much, Martin. Fernando, what is for you the greatest potential? Yeah, we cannot hear you. Yeah, we can hear you now.
Yes, okay, thanks. Sorry for that. Well, I have to, yes, I insist on some of the things that I already mentioned. I think additive manufacture has the potential to revolutionize completely the after-sales market supply chain, which, by the way, that will also have a positive impact on the environmental aspect. you know, with the notion of distributed production. But there's a long list. In our case, for instance, I mentioned that we have used additive manufacturing for rapid prototyping, but I think there's a huge potential to improve and to go even further. So consolidating additive manufacturing to accelerate product and process development. What else can I think? The possibility or the potential of additive manufacturing to help reconditioning the vehicles in their end of life, to extend the vehicle's life. Yes, and the diversity as well. So a lot of potential, a lot of potential.
All right, thank you very much, Fernando. And Stephanie, your point of view on that?
Yeah, so many points have already been mentioned, but what I would like to add is we all had the same problems during the COVID pandemic. So from one day to the other, the supply chains were interrupted. And to be capable of producing, even if it's just for an interim time, additive manufacturing comes in. And I think during that, many decision makers in industry really understood what's the huge potential of additive manufacturing. So securing the supply chains is definitely also a big topic. And you can also save stock costs. So Deutsche Bahn, as a huge railway provider, has spare parts on stock every year worth 600 million euro. Just imagine if you could print 10% out of that on demand when you really need the parts. It's a pure cash out, and what you can do with the money. So there are even more potentials which have not been explored yet.
All right, thank you very much for the input, Stephanie. So, as I said, we talk a lot about safety issues when we speak about people's transportation. There is also the toxicological risks, related to the use of metal powders. So maybe first talk about the security in the transportation. What is for you the actual limitations of additive manufacturing in that sense? And when do you think those barriers can be broken down? Fernando, we'll start with you.
Well, indeed, for the auto industry, especially for new vehicles, the parts needs to go through very strict validation tests. And at least in our case, as I mentioned before, we have found that we have to go through all these processes in a way to compete against, if you wish, processes that have been there for decades or centuries. So that is a challenge. I am afraid I cannot tell you when these will be overcome completely. This will be gradual. It's not impossible to overcome, but this is homework to be done for all of us. And that is for the utilization of parts. Now, then for the use of machines internally, also, as I said before, then there is all this gradual process as well, so that our colleagues from HSC and others internally get acquainted with, familiarize with the risk and preventive measures and with the standards that are currently ongoing. I have as a great example that I think it will be quite useful is the final publishing of the ISO 52931. So that when we started was not there. Yeah. Thank you. That's what I can say.
Thank you very much, Fernando. We'll go to Stephanie. Stephanie, your point of view on that. Stephanie,
I guess I've already mentioned it. Yeah.
Yeah, I don't know. Maybe you had further point, maybe as well on the toxicological risks related to.
Okay. Yeah, you're right. I think the potential is much bigger than the toxicological disadvantages we have. And I think we all have to think more about the advantages of the technologies, especially of metal parts, but not only. We also produce a lot of plastic parts. I think there will be some new technologies be around. So this is what we experience now. There are more and more companies coming up with technologies which are more efficient, and different niches are taken care of. So it's not one machine which fits all, which we had maybe 5 years ago. It's more like different technologies, different materials, and this is what we take care of. And one of the hurdles you also spoke about is the standardization issue. So we have to work on standards to increase the number of printed parts. And this is what we also do jointly in the network, because if every company wants to do that on its own, it will take a long time, a lot of effort, and a lot of money, by the way. And this is why we have to do that jointly.
Yeah, so that makes sense. And last, Martin, if you have another thing to add to that.
Yes, also I agree with Stephanie's point of view, and that's absolutely right. So we need more efficient processes. Of course, we need new machining concepts combined with secure handling processes of powder, for instance, also recycling processes we are working on. And this is not quite a task for only one user of machines. This is a task who can solve by a lot of users, or should be solved, because that's easier, and it's kind also of how many money I can put on these processes to develop. And so it's not, we see this in the last years. In the last years, it was not a revolutionary process, and the enhancements were not revolutionary. And right now, since 2-3 years, a lot of startup companies are coming up with new ideas, with new machining concepts for different materials, absolutely. It makes not easy for us as an automotive OEM to overview the market and the market developments, of course. Also, we are a big player on the market with a huge human capabilities for that. So this is not easy right now, of course. So also we need some guidelines, standardization of processes, and so also new concepts, of course. Yes.
You've just mentioned the new processes, new companies bringing new technologies, etc. Stephanie, do you have actually an idea or an opinion on the greatest technology, of the technology or material that could have the greatest impact in the future?
Oh, that's hard to say. So for railway, it's definitely the printing for big metal parts, and the wire arc additive manufacturing has a huge potential from my point of view. But there are so many more technologies coming up to do smaller or bigger parts. So usually rail is more interested in bigger parts, since the parts which are needed are quite big. But it's really interesting to look on the markets, and I know that we are talking now about metals, but the next big thing which is coming up is printing of concrete. So printing stairways, for instance, is also a huge topic for railway companies. And so one thing follows the other, and the variety of technologies and additive manufacturing will help a lot more for different use cases. And what's also very important is not only the technology in the sense of machines or materials, it's also the software aspect, because now you can also enhance the quality of printed parts by using intelligent software and artificial intelligence driven technologies to save costs, to make it much easier to do the CAD design. And this is also a very important topic which will help all materials and all machines.
All right, thank you very much, Stephanie. Fernando, your opinion on the question?
Yeah, well, yes, I fully share what has just been said. I will add that for auto industry, volumes in terms of number of parts is very important. So everything that contributes to this increasing productivity will help to let's say promote and use more this technology. We heard this morning a very nice presentation from our colleagues and friends from EOS. So we see very rapid development in that sense. Also very rapid developments in metal binder jetting, which I think will help also in productivity. Very important as well, I believe, is all the developments that nearly now at a weekly or monthly basis we read about printing copper. Yeah, so with different technologies that will certainly have an impact on well, the electrification and the drivetrains. Yes. Ms. Brick mentioned concrete. I will mention also composites. Yeah? So I hear also a lot of publications and videos lately about nearly industrial machines that are able to 3D print continuous fiber composites. So all those are great developments that would certainly at some point have a huge impact on the auto industry. Thank you.
All right, Martin, to you.
Nothing more to complete this. I think we know what has happened. We know the bricks in the technology. We know the gaps. But yes, of course, it needs enhancements. It needs also engagement. Also, this is also a human aspect to integrate, to develop these ideas by yourself with your colleagues. You need a motivation, and these motivation have to come from your heart. Yes, and if you don't burn to this technology in that case, then you can develop these processes, and then we can see forward.
All right. Thank you to the three of you. Actually, talking about mobility and being on time is a very good sign. Actually, I'll ask Julie if there is any question. I do believe there are questions from the public side. So Julie, please go ahead.
Yeah, one question from Mrs. Smith. As both the automotive and mobility industry go through big changes to adopt low carbon power sources and electrification, how much is additive manufacturing contributing to reduce weight from vehicles? That will be, I think, to the three of you.
Maybe Stephanie or starting.
To be honest, it's more an automotive question, but of course it also plays a role in rail, since we have to think about alternative ways, and this is something the train producers already think about, like Siemens, Alstom, Bombardier. It's not that much the rail operators, like the railway companies, but it definitely has a potential. But to be honest, it will take some more time to explore the opportunities of lightweight designs. And I think it's a good method to reduce the weight for car bodies. But it's what we struggle still with is the costs. So if you want to bring it in huge series, what you would do when you print new trains, then we still have the problems with the higher costs in additive manufacturing. And I assume, no, I know it's the same problem in automotive. Martin, what do you think?
Yes, it's nearly the same, I think. So, so we have these test parts on test benches. Also, we tested the lightweight design of parts. We know, yes, it could be reliable, but enhancing our complete car manufacturing processes and methods, and also the supply chain. So we manufacture nearly 2,000 cars of the A4 at the daily basis here in Ingolstadt, and the Volkswagen groups manufacture 10 million cars per year, around that. So we can supply to these manufacturing lines directly AM parts. maybe if we count all machines are possible on the market, we say 15,000 machines are on the market, we catch them all, and we want to support the golf production in Wolfsburg, then there would be a part approximately 2 grams or something like that in printed AM material. So you see also there is a problem with the capacity, the process is very slow, the costs are very high, and what we can do is, as OEM, we can see these conventional manufacturing methods, we can enhance these also, and also these methods will be and processes will be enhanced. So I think there is a niche for us. Of course, there is one, but not in these huge serial applications. We are too large for that. Of course, the Audi group is too large for that.
Fernando, an input on the question?
Yes, I mean, I fully agree with what have just been said. We to put it in a slightly different words, but the same information. We have carried out different talks to study the technical feasibility of, for example, suspension parts and topologically optimized. So yes, you can demonstrate it. Of course, you can lose some weight for the lightweighting, but then as it has just been said before, then it comes the economical equation, which is except for very high-end, very small series vehicles, it doesn't work for the time being. And just as a complement, because it's just repeating what my friends before said, then it comes the part which I mentioned before, validation of the guaranteeing the proper of the parts for series production, and that's a challenge, still a challenge for us, whether we make the parts internally or externally. Thank you.
All right, thank you, Julie. Other questions, maybe?
Unfortunately, we still have many, and I fear we're running out of time, so we will take care of it to another occasion, I think. Unfortunately, I apologize to our viewers.
All right, but it was a very interesting panel. Thank you to the three of you for agreeing to joining the panel and giving such interesting information. It's over for the day, for the morning actually. This afternoon we'll have the B2B sessions. I think Julie, you wanted to present as well, give information about an event. But just before that, I'll just remind to the participant that in the document section of GoToWebinar, you can download the magazine of the Chamber of Commerce on the additive markets in Germany. And you'll also find an article in French from a 3DM magazine dedicated to the powder materials. Julie, your turn, of course, to present that Fraunhofer event at the end of May, I think.
Thank you, Guillaume. So yeah, really quickly, because we all want to go in the lunch break. Thank you to all of you on behalf of the Franco-German Chamber of Commerce and Industry for these rich and multilateral discussions of today and these perspectives from both sides of the Rhine, which shed light on many challenges faced in France and Germany today in the additive manufacturing sector. So yeah, firstly, I would like to make you aware shortly about our second day tomorrow of the conference, which will have a focus also on polymers and combined applications in the OEM and aerospace sectors. And secondly, as you know, we as French-German Chamber of Commerce, we have the mission to strengthen the ties between our two countries, and we regularly organize events that bring together the main players of the industry. So our next event, co-organized with the German Technological Center Fraunhofer, you met today Mr. Jochen Lock during our first panel, will take place on the 27th of May and will be dedicated to AM design. So save the date. We will come back to you about it through newsletters, check also our social media, our website. And yeah, we look forward to welcoming you there again virtually to contribute further to the Franco-German industrial cooperation with you. Thank you.
Super. Thank you very much, Julie. Thank you all for participating. And we'll meet again tomorrow morning, 9 a.m. for the polymer section of those Franco-German meetings. For now, very good lunch to everyone. Bon appétit. Good session this afternoon for the B2B. See you tomorrow and keep safe. Bye-bye.
Thank you. Bye.
Goodbye. Thank you.